Assistant General Manager in Punjab Energy Development Agency. Punjab Energy Development Agency is the state nodal agency for promotion and development of new and renewable sources of energy, and working under the guidelines of Ministry of New and Renewable Sources of Energy, Government of India. Second mandate of this department is we are the state designated agency for implementation of Energy Conservation Act 2001 in the state of Punjab. So, as a state designated agency, we are working under the guidelines of Bureau of Energy Efficiency, Ministry of Power, Government of India. So we are the state designated agency having two assignments. That is, one is promotion of new and renewable sources of energy, and another one is energy conservation program in the state of Punjab. So today, because we have been given assignment for discussing about the Energy Conservation Building Code. Today we will discuss about the Energy Conservation Building Code only. Energy Conservation Act has been enacted in 2001, and it is became effective from the 1st March 2002. And Act provides for institutionalizing and strengthening delivery mechanism for energy efficiency program in the country, framework for the much needed coordination between various government entities, then legal framework and regulatory mechanism at the central as well as at the state level. Under the Act, there is a provision to establish a central agency, and the central agency is the Bureau of Energy Efficiency. Under the Act, Bureau of Energy Efficiency has been established by Ministry of Power at the central level. The mission to develop the policy and strategy with thrust on self-regulation and market principles within the overall framework of Energy Conservation Act. Among these stakeholders, there are state designated agencies. All the states have established state designated agencies in consultation with Bureau of Energy Efficiency to implement this act in the states. So Punjab Energy Development Agency is the state designated agency which has been declared on April 2005 for the state of Punjab, and main role of state designated agencies are: this is the development agency, then facilitator to develop the program, then regulatory and enforcing body. We have to guide the people and develop the program, then regulate and enforce it in the state. Energy Conservation Act has been amended in 2010. In the part of this Energy Conservation Building Code, there is amendment in this act. The commercial building having connected load of 100 kilowatt or contract demand of 120 kVA and above come under the purview of Energy Conservation Building Code under Energy Conservation Act. Earlier it was 500 kilowatt. It has been reduced from 500 kilowatt to 100 kilowatt. Energy Conservation Act empowers the central government under Section 14P, read with Section 56, to prescribe Energy Conservation Building Code. This is the provision of the Act. Bureau of Energy Efficiency is mandated to take suitable steps to prescribe guidelines under these laws, and state designated agency can amend these energy conservation building code as per the climatic condition of their state. And the central and state government can direct any consumer under this program to get the energy audits and implementation of energy conservation building code. This is the energy conservation building code, which has been developed by Bureau of Energy Efficiency and launched on 27th May 2007. This has been developed by Bureau of Energy Efficiency and circulated among the stakeholders for voluntarily implementation. As per Energy Conservation Building Code, the climate zone has been divided into 5 zones in India. You can see that hot and dry, it is a red marked in this map. Warm and humid are the coastal areas. Then composite climate is central part of the India. That is, we are also in the composite climate zone. Small is temperate and other is cold, like as Himachal and Jammu and Kashmir and some parts of the eastern states. So 5 climate zone has been made in India. Now, what is ECBC, Energy Conservation Building Code? ECBC defines norms and standard of energy consumption expressed in terms of per square meter of the area where energy is used and include the location of the building. So we can measure this norms into per square meter per year of the area. And ECBC encourages energy efficient building systems such as building envelope, lighting, heating, ventilation and air conditioning, service water heating, and electric power distribution within the building facilities, while enhancing the thermal and visual comfort and productivity of the occupants. The code ensures the construction of energy efficient building with the concomitant reduction in electrical demand. Main issue is to reduce the electrical demand of the building. Purpose of this code. The purpose of Energy Conservation Building Code is to provide minimum requirement for energy efficient design and construction of buildings and their systems. This is the purpose of this code. Scope. The code is applicable to buildings or building complexes that have a connected load of 100 kilowatt or greater or a contract demand of 120 kVA, whichever is greater. Second is buildings or complexes having conditioned area of 1000 square meter or more will fall under this category. The code is presently under voluntarily adoption in the overall country. This code would become mandatory as and when it is notified by the central and the state government in the official gazette. And some states have started it notifying, and Punjab has also notified under by issuing notification this Punjab ECBC. Under this Energy Conservation Building Code, the applicable building systems are 5. One is building envelope, main envelope of the building. Then heating, ventilation and air conditioning. This is the second part. Third part is service hot water heating. Fourth is interior and exterior lighting. And fifth is electrical power and motors. These component systems are under the purview of Energy Conservation Building Code. Exemptions. The code do not apply to one is buildings that do not use either electricity or fossil fuel. Two is equipment and portion of building system that use energy primarily for manufacturing processes. And where energy conservation building code is found to conflict with safety, health, or environmental codes, the safety, health, or environmental codes shall take precedence. So this is the assumption of the energy conservation building code, where you can play with the energy conservation building code for, uh, for its application. This is the overall of the energy conservation building code compliance. Building applying for ECVC compliance, it should meet mandatory provisions. One is prescriptive, another is whole building processes. Either you go to the prescriptive method or you may go to the whole building performance method. In prescriptive method, it specifies prescribed minimum energy efficiency parameters for various component and system of the proposed building. This book has a minimum energy efficiency parameters which you will have to meet with the code, which has been written and calculated as per the climate zones, different climate zones and locations. Or you can adopt a whole building performance method. It is an alternative method to comply with the code and offers considerable design flexibility. It requires an approved computer software program to model a proposed design, determine its annual energy use, and compare it with the standard design. So there is a standard design, and we have proposing a building. So overall energy performance of the building can be calculated through the simulation by the whole building performance, where you can play that in one you have done small activity, in the other you have done more. So overall energy performance of the building should be matched with the requirement that will be given in EPI. You can say energy performance index, which is given in the units kilowatt hour per square meter per year. So annually we can check and approve that drawings. Otherwise, you have to go with the prescriptive methods. Are you understanding this thing? Yeah. Compliance documents. Plan and specifications shall show all pertinent data features of the building, equipment, and system, which includes, we have 5 systems: building envelope, HVAC, service hot water, lighting, and electrical power. And these are some documents which are required to be given with the approval of the drawings. You can say insulation material and their R values. We'll have to mention which material we are using for the building envelope. Then fenestration, what is the glass, what is the windows we are using, and its U factors. Then solar heat gain coefficient calculations. You will have to submit that. Visible light transmittance, air leakage, overhangs, side fins, building envelope, ceilings. Because the building, there is a leakage in the building for heat loss and cooling loss is there. So we'll have to make sure that these should not be there. Then heating, ventilation, and air conditioning systems and equipment types. You have to give equipment size, then type, then efficiency of that system and controls, then economizer, variable speed drives, piping insulation, duct sealing, insulation, and locations, requirement for balance sheet. So This is covered in the HVAC. In hot water requirement, we have to give the details of solar water heating system and other heating equipments. In lighting, lighting schedule showing type, number, and wattage of lamps, and ballast, automatic lighting shut off, occupancy sensors, and other lighting controls, lamp efficacy for external lamps. So these are requirements which are to be given with the plan sanction. Electrical power, electrical schedule showing transformer, losses, motor efficiency, power factor correction devices, electric check metering and monitoring systems. So these are covered in the Energy Conservation Building Code, which are required to be given with the drawings. This is some outline in building. Heat transfer is there, ECBC requirement are there, cool roofs you can provide in which prescriptive requirements are given, penetration, then it is also a heat transfer. ECBC requirements are there, air leakage, ECBC mandatory requirements are there. So then ECBC compliance forms are there, which are required to be filled up and submitted along with the drawings. So building in the building envelope, there is a two type system, you can say opaque construction. One is walls, roofs, and floors. These are opaque. Another one is fenestrations in windows. Then doors can be for glasses and then skylights. So these are covered in the building envelope for the external environment from the exterior spaces. Then building envelope design considerations. For the designing building envelope component design, one is, another is building material specification. Both things are to be calculated. In design area, orientation, tilt of the building, roof form design, choice of shading devices, penetration size, placement of window, construction specification. These are covered in the building envelope design. And accordingly, with that, the material specifications like as insulating properties, ULUs, SG, SC, emissivity, and cool color and textures. These are to be given. And you can see that there is two pictures. One is building in cooling mode. When the building is in cooling mode, there is a heat gain through the roof. 30%, up to 35%, you can say the heat is coming from the roof, and 25% heat is coming from the wall. Then heat gain through the wall. Then heat gain through the solar sunlight, daylighting. Then heat gain through glasses. Then heat gain with the occupancy. You can, persons are working, they are also creating heat. Then lighting fixtures are also cause of heat gain. And in the heating mode, there are losses, heat losses from the roof, heat losses from the walls, then heat losses through glasses. So these are two systems when you are in winter position, when you are in summer position. Both are required to be calculated while designing the building. Heat transfers. Mode of heat transfer are three, as you know: conduction, convection, and radiation. So ECBC role in regulating heat transfer. In conduction, you will have to check U factor, R value of roofs and walls. In convection, building envelope ceiling, requirements. Then in radiation, you will have to check R values of the roofs and walls, or cool roof, you can check and apply the systems. Now R value. What is R value? R value is the thermal resistance of the element, and R value is equal to the thickness of the material divided by thermal conductivity of the material, that is K value. So R is equal to D over K. When you are calculating with the multi-layered component, then RT is equal to D1 over K1 plus D2 over K2. You can go to the Dn over Kn. So you can see the in the figures, conductivity, thickness in meters, indoor surface temperature and outdoor surface temperature. You'll have to check that. Effectiveness of thermal insulation to retard the heat flow. And you will have to remember that high R value indicates higher insulating property. So unit of this R value is meter square K per watt. This is the unit of the thermal resistance. So you can calculate with this, and this figure is required to be given on the pamphlets giving the material to us by the manufacturer. You will have to check it. Then U value. U value is a thermal conductance as a heat transfer coefficient. It means U is equal to 1 over R. This is inverse of the resistance. Measure heat transfer through the envelope due to temperature difference between the indoor and outdoor. A unit of a watt per meter square K. U factor of the composite wall roof assembly as 1 by RT. Rate of heat flow, therefore, lower number are better. In this case, lower number is better, and on that case, in R value, higher number is better. Building insulation. One of the ways to improve energy efficiency, especially in air-conditioned buildings, has high R value. So increase thermal comfort in cooling and heating mode, helps in reducing the heating and cooling costs. You can see that in summer and in winter. In summer, from roof, we are receiving 25 to 35% heat. From walls, 15 to 25%. And from the windows, which are glazed windows, 25 to 35%. And you can see that there is a air leakage. And this factor is 5 to 15% in the summer heat gain. In winter heat loss, 25 to 35% roof from the roof, and 15 to 25% from the walls. The same figures almost. And the addition is that you are also losing heat through floor. That is 10 to 20%. And from the air leakage, it is very important in the winter. Air leakage is more than air leakage working in summer gains. So 15 to 25% we are losing with the in air leakage in the winter. So we have to check these things while designing the building. ECBC requirement of opaque wall. When you are designing a opaque wall, the climate zone where you are required to design a building, if you are in the composite climate zone, then maximum U factor of the overall assembly should be 0.44. And minimum R value insulation alone is 2.1. This is for the hospitals, hotels, call centers. That buildings are almost totally air conditioned. And for the other buildings, the figures are different. So these figures have already been given in the Energy Conservation Building Code. We'll have to check we are meeting that or not. Then ECBC requirement of roofs. Maximum U factor is prescribed for the complete roof assembly. And the minimum R value is also prescribed for the insulation. You can see that in here 24 hours huge buildings are hospital, hotels, and daytime huge buildings are there. And the figures are not the same. You can say that in composite climate zone, the U factors in hospital or hotels 0.261 and minimum R value is 3.1. On the other side, when the building is daytime use, then 0.409 U value and R value is 2.1. You can see that where are you designing the building, where is the location, then you can decide accordingly. This is very important factor, that is solar heat gain coefficient. Solar heat gain coefficient is the ratio of solar heat gain that passes through fenestration to the total incident solar radiation that falls in the fenestration. You can see in the figure outside and inside. From outside, incident solar radiation is coming and somewhat reflected back, and other are indirectly transmitted heat, that is A, B, C. And there are some absorption of heat with the assembly, and after absorption there is a re-emitting and inside and outside both. So you have to calculate all these calculations while calculating the solar heat gain coefficient. So that is the ratio of the solar heat gain that passes through penetration to the total incident solar radiation. That indicates how well penetration insulates heat caused by direct solar rays. Lower solar heat gain coefficient means lesser heat transfer into the building through the windows. It depends on properties of the glazing material and window operations. And that is also depend upon the operation, whether fixed window or openable window. In hot climate, the solar heat gain is more significant than U factors. So it is required to be, it is a very important factor which is required to be calculated while designing the building as per Energy Conservation Building Code. Now we come to the envelope sealing. Building envelope shall be sealed, gasketed, or weather stripped to minimize the air leakage. It is very important in this Energy Conservation Building Code. Joints around the fenestration and door frames. You can see that when the glass is fixed with the wood partition, wood component, and then it is joined with the walls, there are leakages. It is required to be sealed properly. Opening between the wall and foundation, and between walls and roof and wall panels, there are some openings, holes that is required to be sealed. Opening at penetration of utility services, when you are crossing the wires, when you are crossing the pipes, then there are some leakages that is required to be sealed in roofs, walls, and floors. Then site-built fenestration and doors, building assemblies used as duct and all other openings in the building envelope. You will have to see all the openings, all the leakages in the building while you are checking the building. This is the ECBC compliance form. You can see that there is a two-part. One is envelope summary. When you have designed the envelope, you will have to enter figures in the summary, to jot down that in the summary sheet. Then building permit plan checklist. Then you can enter that and give the remarks accordingly in the checklist. So this is required. This form is required to be submitted with the energy with the drawings plans when you are submitting for the approval. Then you come to heating, ventilation, and air conditioning. In heating, ventilation, and air conditioning, natural ventilation shall comply with the design guidelines provided from natural ventilation in the National Building Code. You have to refer National Building Code, Part 8, Section 1, 5.43, 4.3, and 5.7.1. Two sections you are required to read it while recommending and designing the HVAC. On the other side, when you are applying the unitary air conditioners, it shall meet IS 1391. Part 1. Split air conditioners shall be IS 1391 Part 2. Packed air conditioners shall meet IS 8148. And boilers shall meet IS 13980 with 75% thermal efficiency. This is the requirement of the code, and you will have to refer these IS while checking this HVACs and or the unitary air conditioners being provided over there. All mechanical cooling and heating systems shall be controlled in time clock. It is very important. These systems, whatever you are providing, this should be controlled by the time clock. All heating and cooling equipment shall be temperature controlled. Piping and duct work shall be properly insulated. These are given in the tables in the energy conservation building codes. The details are given in that. You can check with that. All high-rise building using centralized cooling water system shall use soft water for condenser and chilled water systems. So these are the requirement for the HVAC, because HVAC is the manufactured item and you will have to buy with these conditions, and you will have to check the IS code before procuring the this HVAC system or the air conditioner systems to be provided in the building. Then come to the service hot water and pumping. Residential facilities, hotels, and hospitals with a centralized system shall have solar water heating for at least 1/5 of the design capacity. Whatever is the requirement of the hot water, you will have to meet 1/5 with the solar water heating system, and other with the other system. You can use electrical heating, you can use gas heating. Second is service water heating equipment shall meet or exceed the performance and minimum requirement presented in available Indian standards. Then solar water heating system as per IS 13129 part 1 and 2. You will have to refer that. Gas instantaneous water heaters as per IS 15558 with above 80% thermal efficiency. It is the requirement of the code. It should be 80% thermal efficient. Electrical water heater as per IS 2082. The entire hot water system, including the storage tanks, pipeline shall be insulated, conforming to the relevant IS standards or material and applications. There are IS codes for the insulations also. You will have to check while checking the pipeline and storage water, hot storage water for its insulations. You will have to check it. The design should ensure that at least 20% of the heating requirement shall be met from solar heat or heat recovery, and not more than 80% of the heat shall be met from electrical heating. This is the code requirement. 20% from solar water heating system, not more than 80% from the electrical heating. But whenever gas is available, not more than 20% of heating shall be met from the electrical heating. Where gas is available, you can't go for electrical heating beyond 20%. So this is the requirement of the code. We'll have to meet that. Are you understanding now? Anything you want to discuss at this stage? No? Now lighting. Lighting is the major energy consuming component in the commercial buildings. Lighting accounts for 15% of total energy consumption in India, and commercial buildings are using 20 to 40% electrical load in lighting. In most commercial buildings, lighting is one of the largest source of internal heat gain. It is very important. You can see that heat generated from electric lighting contributions significantly to the energy needs needed for the cooling of the building. And each kilowatt hours reduction in lighting energy approximately saves 0.4 kilowatt hours in cooling energy. If you are reducing 1 kilowatt, then 0.41 kilowatt hour cooling load can be saved with that. So you are required to take care of the lighting systems which are creating heat inside, so that the cooling load can be reduced accordingly. So this is the factor, this is the thumb rule. You can note and you can use this, you can take in mind while taking care of the heating of with the electrical fixtures. Lighting is one of the fastest developing energy efficient technology, and there are different components are coming. Energy efficient lighting are coming in LED also. ECBC requirement for the lighting system. Automatic lighting control. Interior lighting system in building larger than 500 square meter or 5,000 square feet shall be equipped with an automatic control device. It is important and it is required to be provided. All office area less than 30 meters square shall be equipped with occupancy sensors. You know about occupancy sensor? When you are occupying the space, the lights are on. When you are going back, and the lights are off. So occupancy sensors are required to be provided in this. For other spaces, this automatic control device shall function on either one is a scheduled basis at specific programmed times. An independent program schedule shall be provided for area of no more than 2500 square meter and not more than one floor, or occupancy sensor that shall turn the lighting off within 30 minutes. This is the limit of the occupancy sensor of an occupant leaving the space. Lighting fixtures controlled by occupancy sensor shall have a wall-mounted manual switch capable of turning off lights when the space is occupied. It is also required to be provided there. Manual switch is also very important because after evening you can put off manual switch and it should be controlled by that. Space control. Each space shall have at least one control device to independently control the general lighting. For the general lighting, we have switches one for one, but in general lighting, it is required to be grouped. Each control device shall be activated either manually by an occupant or automatically by sensing an occupants. Each control device shall control a maximum of 250 square meter for a space less than or equal to 1000 square meter and a maximum of 1000 square meter for a space greater than 1000 square meter. Be capable of overriding the shut-off control required in the automatic lighting shut-off for no more than 2 hours. Be readily accessible and located so that the occupants can see the control. It is very important the control should be in visible or accessible place. Daylighting control. If daylighting strategy is used in the design, Energy Conservation Building Code requires controls that can reduce the light output of luminaire in the daylit space. It should be controlled by the device. Luminaires in daylighted area greater than 25 square meter shall be equipped with either a manual or automatic control device that is capable of reducing the light output of the luminaire in the daylighted area by at least 50%. Dimming should be there. Controls only the luminaires located entirely within the daylighted area. There are also control requirements for exterior lighting with photo sensors or time switches. And specialty lighting applications like display, hotel rooms, task lighting, they are required to be controlled automatically with the photo sensors or the time switches. Exit signs. In exit signs, there is a limit for 5 watt per phase. So you can check that the 5 watt is used in the signing. Exterior building grounds lights. Lighting for exterior building grounds luminaires which operate at greater than 100 watt shall contain lamps having a minimum efficacy of 16 lumen per watt, unless the luminaire is controlled by the motion sensor. If there is a motion sensor, you can provide that, but the 60 lumens per watt is the limit for providing the lights. ECBC requirement for lighting, you can see that interior lighting power building area method, in which you can see that building area and lighting density, that is watt per meter square. Lighting power density, this is LPD. So you can see that the automotive facility 9.7 watt per meter square, and at the same time you can see dining bar lounge, it is required 14, dormitory it required 10.8, gymnasium 11.8, and multi-family residential is 7.5. These are the limits where you have to limit for the energy conservation building code in lighting system. So these are the LPD mentioned in the energy conservation building code while designing the building, and area wise you can design the lighting system. In interior lighting, power space fixtures, space function method, these are the limits. Both limits are given for that. Electrical power and motors. This is the fifth component of the energy conservation building code. And power transformers of the proper rating and design must be selected to satisfy the minimum acceptability efficiency at 50% and at full load. When you are giving full load on the transformers, the losses should be not more than 50%. It is a requirement of the energy conservation building code. All permanently wired polyphase motors of 1.375 kilowatt or more serving the building and expected to operate more than 1500 hours per year shall be not less than IS 12615 for energy efficient motors. And motor horsepower rating shall not exceed 20% of the calculated maximum load being served. So if you require 1 horsepower motor and you are providing 2 horsepower, so you are exceeding 50% more. So you can't exceed 20% while designing the this motor horsepowers. So this is the limit given in the energy conservation building code. Because if we are using 2 horsepower instead of 1 horsepower, we are consuming double the electricity. So you can exceed only up to 20%, not more than 20% in the horsepower rating system. All electricity supplies exceeding 100 ampere, 3 phases shall maintain their power factor between 0.95. This is the limit. While you are procuring any component, you must see that its power factor should be more than 0.95. Because less than 0.95 are consuming more electricity. So it is required to be checked. Services exceeding 1000 kVA shall have permanently installed electrical metering to record demand, energy, and total power factor. The reading should be there. When you are servicing 1000 kVA, so the recording should be for kVA and for kilowatt hours and the total power factor. It should be there. The power cabling shall be adequately sized as to maintain the distribution losses not to exceed 1% of the total power usage. So that power cables are required to be used, which are not exceeding the 1% losses in the distribution. So this is the limit of the energy conservation building code. This is the compliant tool which has been given with the energy conservation building code, that is Eco-Nirman. There are 2 versions, Eco-Nirman Perspective and Eco-Nirman Whole Building Performance. And these are available free of cost. You can download and you can read this, and you can also practice via for the use of energy conservation building code. This is the software given by the Government of India. Now, as I have already told you that any state, any can amend this energy conservation building code, which I have discussed with you, with the climate conditions. So Punjab is covered under composite climate zone, and PEDA, Punjab Energy Development Agency, has developed the Punjab Energy Conservation Building Code applicable for the state of Punjab, which is according to the composite climate zone, and it has been accepted and notified by the government on 24th June 2016, and which is now mandatory for application in the state of Punjab. Main salient features of this have given limit same as the central 100 kilowatt and 120 kVA contract demand, but conditioned area we have reduced from 1000 to 500 square meter. This is the difference between the both. And we have also covered all building complexes such as offices, hotels, shopping complexes, group housing complexes, private hospitals, and other that are not primarily for the industrial, that is manufacturing processes. And we have also added star labeling and minimum star rating for the equipments being used in the buildings. You can see, you must have seen that there are star rating from 1 star to 5 star in the electrical equipments. You can see in the market that 1 star to 5 stars are available, and 5 star is the most energy efficient equipment in every equipment of electrical appliances. That is, if you are going to purchase the unitary air conditioners, there are 1 star to 5 star, and 5 star is the most efficient in the electrical powers. So such as every electrical component, electrical equipments are being starred by the Bureau of Energy Efficiency, and we have made mandatory as 3 star in the Punjab Energy Conservation Building Code. In addition, it has also been proposed to have automatic shut-off, where they have given 30 minutes and we have given 10 minutes. This is the difference between the central and the state code. Then HVAC, we have given the same, but window and glass we have limited to 40% of the window should be allowed for the type of climate of state of Punjab, and the solar heat gain coefficient of the glass to be given in the Punjab ACBC. This has been prescribed in the Energy Conservation Building Code. This is the notification issued by the Department of Housing and Urban, Government of Punjab, where provision of this Punjab Energy Conservation Building Code is given, and they have mentioned that they will give an incentive of 50% refund of building security fee permissible on completion of the building on production of certificate from the competent authority. This is the provision, and this is the incentive given by the Department of Housing and Urban, and this has been given in the building bylaws, revised building bylaws. On the other side, if you are designing the building as a green building under GRIHA or IGBC, then an additional 5% floor area ratio free of charge shall be permissible to the eco-friendly buildings. The promoter has to provide certificate from Bureau of Energy Efficiency or GRIHA from Ministry of this New and Renewable Sources of Energy. However, in case of a promoter fails to submit maintenance certificate after a period of every 5 years from the competent authority, the defaulter can be penalized at the rate of 200% of the additional floor area ratio permitted. This is given in the building bylaws, And now that recently the local government has also notified the Punjab Municipal Green Building Incentive Policy. They have made a policy for that, and they are giving incentive of 15% rebate in property tax. You can see that even you can save in the property tax also up to 15% till the time building is built with the Punjab Energy Conservation Building Code. Incentive under other rating system, they have given an incentive of additional 5% FAR. And the agencies covered are building granted 4 or 5 star rating in Griha, building granted gold or platinum rating by LEED, or building granted gold or platinum rating in IGBC. There are 3 ratings in the India, and you can avail any of this. This incentive shall be applicable to residential and non-residential building on plot size above 100 square meter. You can avail this facility of incentive. But there are conditions for this incentive. Grant of incentive of additional FAR shall be provisional till final completion certificate is obtained by the applicant within the prescribed period. It is the requirement. Grant of incentive of additional FAR shall not be in contravention of any building bylaws. Grant of incentive of property tax or additional FAR shall be reviewed every 3 years. This provision, this incentive is required to be reviewed after every 3 years. In case of non-compliance of above conditions, or upon failure to obtain or retain the minimum rating prescribed above, a penalty equivalent to 5 times of the collector rate of land proportion to the 5% additional FAR shall be imposed for the building availing additional FAR. So this is the condition when you are not maintaining this provision, the Energy Conservation Building Code. After 3 years, you will have to penalize accordingly. In case of buildings obtaining more than 1 green building certification from ECBC or the other rating system, then only one of the incentive at the time shall be applicable. So both you can avail one incentive from that. So this is all from my side. If you have some questions, you can raise some questions. Now we are also, this is Energy Conservation Building Code. It is being read by the departments and the other stakeholders. For the facility of implementation and to ease the implementation of this Energy Conservation Building Code, we have started a 2-tier system of training. One is a capacity building program. In capacity building program, we have made one program of 1 year, and we are providing training. 37 trainings are being provided all over the Punjab. Some are 1-day training, then 2-day training and 3-day training. 20 trainings of 1 day, and 13 trainings are having 2 days, and 4 trainings are 3 days. From which in the 1 day we are giving general training about the Energy Conservation Building Code. In the 2 days we are also providing the tools, and we are also guiding it in details. And in the 3 days there is a total detailed training on this Energy Conservation Building Code, where we are giving the certificate of the energy professionals. So we are going to certifying the energy professionals so that the capacity of the stakeholders can be enhanced and implementation can be done in proper ways. On the other side, one tier is this, and on the other tier, we have also established a Punjab ECBC cell in our office. In PEDA office, Punjab Energy Development Agency office in Sector 33, and we have established one group that is called as Punjab ECBC cell. That cell is interacting with the different departments, organizations, architects, and building professionals, and also going through the processes of approval of drawings and its implementation, its supervision. They are helping to all the stakeholders, either it is architect, either is a professional designer, or it may be a builder, it may be a government servant who is checking it for regulatory mechanism. All help is giving by Punjab ECBC cell. They are a group of 4 people, and 2 engineers. This can be availed at any time for any clarification of this energy conservation building code. Is it Chandigarh University? Any question from Chandigarh University? Any queries, any clarification required for the energy conservation building code from the Chandigarh University?
Thank you, sir. No queries as such. Thank you, sir. It was
Any other centers?
I'm from IC University. Hello.
Yeah.
Hello, sir. My name is Kushal. I'm from Afghanistan and I'm studying in IC University in 3rd year.
Okay.
Sir, actually, I have 2 questions regarding green building.
Right.
Sir, my first question is this: that what standards exist for green building? And my second question is, sir, how will green building improve level of performance of the homes? These are my 2 questions, sir.
For this, I have to clarify that green building is not a simple building that can be rated by somebody. And we have 3 system of rating in India. One is IGBC rating, another is Griha rating, and the third is the LEED rating. And if you are going to the Griha rating, there are 1 star to 5 star rating in the green buildings, and we'll have to follow the criteria of the green building system that is given at by the Griha, and 34 criteria are given differently for from designing stage to the construction stage, and even after use of the building. And you have to comply that 34 criteria, and you should have minimum 50 marks from 100 to certify that building as Griha rating, one Griha rating, and then 1 to 5, maximum is the 5-star rating in the Griha. And on the other side, there are IGBC rating, which is given by the IGBC Center, Hyderabad. And there are 4 type of rating. One is certified, another is silver, then gold and platinum. 4 type of rating are given. Platinum rating is the highest rating, in which the building is consuming less energy, and that is eco-friendly building. And you can avail also that. You will have to meet that requirements which are given in the criteria of the certifying authority. So these are the authorities, 3 authorities. You will have to meet all criteria of that to get the certification of the building. That certified building is called as the green building. And in Energy Conservation Building Code, it is covered under the Energy Conservation Act 2001. This is the mandatory one from the Government of India.
Okay, sir. Thank you so much.
Thank you.
Thank you, sir.
Myself.
Thank you. Thank you very much. Any question from your side?
Good morning, sir.
Good morning.
Myself, Indu Palkot. I am in 6th semester in IC University. And my question regarding to green building is that which material is better, an recycled material or a natural material?
Pardon again. You can again explain it. Query is required.
Sir, hello, sir. Which material is better according to green building, a recycled material or a natural material?
Which material?
A recycled one or a natural one?
Both are good one. Recycled one is more better than that of natural one. Hello.
Hello, sir.
Recycled is more better than that of other.
So why recycled is more better than natural one?
Because we are also using the used material, and where we are using fresh, and on the other side we are using recycled. That means the used material is being again used. We are not required to take a fresh one.
Okay.
Hello.
Hello.
Good morning, sir. This is Himanshu Sharma from Maharaja Agrawal University.
Okay.
Some of our students want to know what is the effect of the cost of green building as comparison with normal buildings.
There are some increase from 10 to 20% in the cost.
Increase in cost.
Yeah. But it is recovered in the life cycle within 2 to 5 years.
Within 2 to 5 years.
Yeah.
Thank you very much, sir.
Thank you. Any others? Thank you. Thank you very much.
How to get back to the first one? I do not know. This mouse is not responding.
Just use this.
Further, I have to move it with the mouse or how? Okay.
Back.
Shall I start? Good morning, ladies and gentlemen. I hope all the centers are on. I'm Colonel Harry Sidhu, retired. I shall be talking to you on the building envelope. I shall briefly introduce myself to you all. I'm a visiting faculty to this institution. I'm the member of the Board of Studies, Punjab University, external examiner for ME and MTech students of IIT Mumbai, Punjab University, and TIT Patiala. I'm a consultant for structural design and rehabilitation and waterproofing, an expert columnist to Hindustan Times on waterproofing and building maintenance, and Director Technical Build Care Services India Private Limited. The building envelope. Today, with the emphasis on green building construction, we have a lot of emphasis on saving energy, because the energy around us is not unlimited. The resources that we have at our disposal in the universe are limited, and most of them are not renewable in nature. So we have a very big importance to conserving that energy. And the building envelope, as I shall be describing further on, is one of the major aspects which helps us in saving the energy. For having a sustainable design, the building envelope is a very, very significant thing. Now, what is the building envelope? You have the building as a whole and everything that is on the exterior, which is surrounding it, the external walls, the windows and openings and all other things, the roof, they comprise of the building envelope. The figure on the right shows you a diagrammatic sketch as to what defines the building envelope. During its normal time of maintenance and in the day-to-day occurrence, you have various things like the rain, the solar radiation, and the wind, and the snow cover which affects that building. You have the rain which wants the water to get inside. We want to avoid that water from getting inside. You have the solar radiation which creates the heat externally, and we want to prevent that heat from getting inside to make the interior as comfortable as possible. Then you have the soil environment, the mechanical equipment inside, and the occupant activity itself. They are all generating heat, consuming it, or producing it. You want to control all this without any extra effort. The building envelope, the outer wall, roof designed to influence and regulate the comfort requirements of the user inside the building, that is conforming the building envelope. Like our own skin and clothing, this envelope fulfills the following functions such as the protection from heat and cold, glare protection, ventilation, and provide visual contact between the inside and the outside of the building. Now, what are the considerations? In the former times, the construction and appearance of the facade were of major concern. But today, we need an integration of the functional quality, thermal performance of the facade, structural performance, aesthetic aspects, and comfort for reduced energy demand on renewable energy. That is the central requirement. Now, how do you define sustainable development as an organizing principle for the human life on a finite planet in which the living conditions and the resources used meet human needs without undermining the needs of the future generation? You see, this is the situation that you cannot keep on consuming your resources, because if we consume everything, what will be left behind for our future generations? The future generations are dependent upon what we are going to leave for them. So that is very, very important, because it is basically a thought process, a thing that we got to understand. It is a psychology that we have to develop, that we do not have to fritter away the scarce resources that we have at our disposal. That is how the Wikipedia, the open dictionary, defines it. Now, sustainable development is the kind of development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. That is the Bertland Commission, which was ordered in 1987. That is how they defined it. Basically, Wikipedia and the Bertland Commission are talking of the same thing. Envelope design and sustainability. Now, what do you understand by sustainability? Sustainability is something, to give you a very, very common example, everybody can probably buy anything that he wants to within reasonable means. Like supposing you want to buy a car. You buy a car, you get a loan from the bank, or you use your existing resources, but will you be able to sustain it? Will you be able to run it? Will you be able to find money for the maintenance cost, the running cost? So similarly, we are dependent upon the nature for our everyday existence. So we have to use water, we have to use air, we have to use power, we have to use energy. Now these things are not unlimited. We have to use those things in such a manner that those limited resources are not misused. We have to leave something behind, like the petroleum and resources. The petroleum is not unlimited. You see, the complete world economy is based around petroleum. The oil prices go up, the world economy gets affected. So we have to use those things in a very, very judicious manner, so that we do not consume away everything. We should not be able to say that what does it affect, how does it affect me? I have got it, but we've got to remember that we are future generations. They are also going to utilize the same energy and the same resources. So that is what is called the sustainability. You should be able to sustain whatever you've got in hand. Now, envelope design and sustainability. The building envelope, the exterior, where we live, and we spend at least about 80% of our living time, whether inside our office, whether inside our home, it is only a little amount of time that we are spending outside. So the building envelope, as I will show you as we proceed further, is something which is controlling this use of energy. Now, what are the elements involved in the building design? Firstly, it is supposed to be a load-bearing structure or a frame structure, whatever it is. It is a structure by itself which is involved in the building load-bearing design. The mechanical services. the various things like lifts, that the ramps and elevators, and so many other things that are going inside the building, they are all consuming energy. The spatial framework, the overall, the structure and the space, this framework is also affecting the energy demand. The building skin is the most dominant. As you will see as we proceed further, that out of all these things, all other things have got something or the other to control their use. But the building skin is the most dominant thing that can be utilized without consuming any extra power. Now, functions of the building skin. What does the building exterior? Let's use that word exterior, because that will be more easily understood. What are the functions? Ensure comfortable indoor conditions. Outside may be very cold, outside may be very hot, but we've got to have an interior temperature which is conducive to our personal requirement. Control the energy consumption. Whatever is, supposing it is not able to control the heat ingress inside and outside, we got to use artificial devices. You got to use air conditioners, you got to use heaters. So if our energy requirement is controlled by the skin itself, the use of these external agencies will accordingly be reduced. Now it can control all comfort related parameters except relative indoor humidity. You understand what is humidity? Humidity is the amount of moisture that is present in the atmosphere. We can control everything, but we cannot control relative humidity. Do you agree with me on this? Relative humidity is something like during the monsoons. The relative humidity goes up very high, it becomes uncomfortable. जिसको अपनी भाषा में हम हुम्स कहते हैं, हुम हो गया. There is nothing that can be done except for ventilation, which can be used to reduce the relative humidity. So the building skin, the building exterior can do everything except control only one parameter, and that is the relative humidity. That we have to use some external devices, external means like dehumidifiers, forced ventilation. So this is the thing, only thing that the building skin is not able to control. The thermal transmission. You see, whatever is the heat that is traveling from inside to outside is directly controlled by your building skin, the building exterior. The total solar energy, the solar energy that the building absorbs is again dependent upon your building skin. Daylight transmission. You see, you've got curtains over here, but if you raise those curtains, you'll have probably no requirement of the light inside. So that much energy which is utilized for lighting up this interior can accordingly be saved. But then don't say that these curtains are not required. They are required for the purpose of preventing glare. So you got to strike a compromise where glare is not important. You can probably avoid using curtains. Energy consumption. This is all interrelated. Whatever is the energy that we are consuming, they're all dependent upon the various other factors. So this is all linked with when the building skin is able to control those, the energy consumption will get reduced. The sun protection system. Ladies and gentlemen, without any doubt, the sun is the most powerful thing in this universe. Without this, nothing can exist. But then it has certain issues involved, because of which we've got to control the solar energy. The sun, when it is shining too brightly, will heat up our environment to make it unbearable. The sun, when it is not there, will create an environment which will make it again unbearable. So we got to utilize the solar energy in our own form, in the manner in which it suits us. Solar energy is one energy which is free. You don't have to spend anything for creating the solar energy. Nature has provided us that. But then we've got to use it judiciously, correctly. Avoid the extra, cut out the extra solar energy and harness the powers of the solar energy, like your thermal heaters, the solar heaters, the solar panels. You've got to utilize them properly. But then, for the purpose of the skin properly, the sun protection system, independent of the heat insulation factor of a transparent facade, the placement of the sun protection system has an influence on the energy consumption of the building. Now, I'll explain this with the help of a couple of photographs. You got to cut out the solar energy, but where you provide that filter, where do you provide that cutout device affects the energy consumption. You see, this earlier times we used to have chhajjas, but then the chhajjas had certain inherent disadvantages. One disadvantage was they were not looking good. The other thing, problems of waterproofing. Water used to accumulate and they used to present an unsightly appearance. But then with the advent of newer and newer systems, you have things which are not preventing your water from free flow, and at the same time, what do you want? You want that chhajja to provide shade to your opening. So you have chhajjas. You've seen these kind of things in many buildings these days, with the result that the wind flow, the water flow is not affected. The waterproofing is not affected, but then they provide the shade when the sun is directly above you or is trying to enter into your windows. So these are the two types of things. Remember, conventional facades with east or west orientation show energy consumption to be halved. It becomes half if you prevent these kinds of blinds. Remember this word. When I go to the next slide, I'll revert back to you for this thought. Then you have these kind of blinds that are there inside this room itself. Very, very commonly used. They are also trying to prevent the external energy from coming inside. But then internal blinds reduce the energy consumption by not more than 20%. You see, externally, when provided, they prevent 50% protection. But when the same thing is provided from inside, the protection is only 20%. Why? Because the external thing is firstly cutting out the heat energy from coming inside. So that much energy is reduced from getting affected. Whereas in the case of the internal blind, the solar energy has already come inside and then being blocked by that artificial curtain. So the effect is about 50% reduced to 20%. So olden times, people never used to use curtains. During summer, they used to use chicks. You understand what I mean by chicks? Those bamboo strips which are hung outside. So our ancestors had a better understanding about solar energy. That is why during summers, they used to have that khaski chatti, that same chick made out of husk, which could be used for entrapping water and allowing cooler breeze to come inside. So those are the things. You see, when we are talking, we must learn from the past. Our ancestors, they were not having all this latest technologies available to them. So they were utilizing whatever was the best possible thing available in nature. So that is the difference between the external blinds and the internal blinds. Hope that is understood. Now, anti-glare system. With the progress of time, glare has become a very big enemy for the human eyes. Particularly in the case of our modern day systems. Let's see, the main task of anti-glare system is to prevent extreme contrast in lighting intensity. An issue which is especially important in office buildings with monitor workstations and visual comfort must be maintained. We are exposed to so much of glare from the computer screens that our eyes are not able to absorb that glare. Are you all aware of this all? Those of you who are not aware, please remember that constant exposure to the glare inside your office buildings and particularly your computer screens can lead to an eye disease called dry eyes. Have you heard of this term, dry eyes? Dry eyes is something where you got to concentrate more. You got to compress your retina to reduce the inlet of energy, light energy into your eyes. That affects your retina, with the result that your eyes start watering. Eyes start watering and the disease is called dry eyes. A contradictory statement, but because they are dry, your eye has to blink more than required. You see, your eyes require lubrication. And your tear glands are there to provide lubrication to your eyes. But then when the eyes become dry, actually they are becoming dry, that is why you are blinking more. You'll realize that when you are exposed to glare, you blink your eyes more than normal. Am I right? This is a normal day occurrence. It's a normal observation. When you are blinking more, what is happening? Your eyes are producing more tears. And why they are producing more tears is because your eyes are requiring lubrication. In that process, the extra amount of tears, the water starts coming out. The tears start coming out. That is why it is called dry eyes. Though this is not a thing related to this topic, but as a matter of general sharing, to avoid that kind of a situation, when because you cannot avoid using computers. Today it's become an essential requirement. Whether we say that it is harmful or we say, and it has become more compounded with the onset of smartphones. At least the computer has got a bigger screen and you maintain at least some reasonable distance. But your smartphones, you're holding it like this. The same glare is now affecting you in a more concentrated manner. Your eye is concentrating, focused onto that small little screen. So what are the precautions? I shall share with you the precautions out of general knowledge, general interest. Firstly, do not look at the screen, computer, or your smartphone for a continuous period of more than 15 minutes. After using any of these gadgets for 15 minutes, please try to look away. Look away into the distance, not a thing which is as close as that, so that your eye muscles are relaxed. Try to press your eyes force your eyes to closure so that your muscles are exercised. And after a gap of about a minute or two, then you could resume your work, so that your eye has been relieved of that stress. Secondly, never place your computer screen lower than your eye level. Your computer, sorry, I stand corrected. It should always be lower than your eye level. Correction, please ignore what I said earlier. Your chair should be placed so at such a level that you have to look down toward the screen and not look up, because your system is adjusted in a better manner. And after constantly using your computer for more than about 45 minutes to 1 hour, take a break, take a stroll. Turn away from your computer, take a stroll inside your room itself for about 5 minutes and then get back to work. This is, of course, the medical side, but then I thought it is relevant to the glare part. I must share with the young audience that I'm speaking to. Now, what are the anti-glare systems which are available to us? You have the sun protection films. They're very, very common, even in your vehicles, though, of course, now the police forces, they are objecting to it. But then these are transparent screens of different intensities which are pasted on your glass to cut out the glare from outside to inside. You're all aware of this kind of a thing? Then you have your lights, like even your lights inside, they are covered with frosted glass or reflectors, so that the direct light is not coming inside and shade is not created and glare is cut out. So these are anti-glare fittings. The electrical lights have got anti-glare fittings. Now, daylight use. One side, we are counting it harmful. The other side, we must utilize the daylight use to our advantage. The use of natural daylight is increasingly important, both in terms of comfort and contentment of the users, and with regard to reducing the requirement of artificial light. So this is both, that it is reducing your power consumption, and at the same time, it is improving your satisfaction level, because there is nothing more soothing than the natural light. Artificial light is always painful. So you go to properly designed offices, and I have been to offices where you don't find a single light on during the daytime. You drive around that Gurgaon highway, you find that glass facade buildings. So much of light, natural light is coming inside, that the workstations do not have to be lighted up. The natural light, there is not a single light being switched on during the daytime. So that is how you're going to utilize that natural light and in effect reduce your energy demand. You see, you have that kind of a glass face on one side. And here are two examples I'm showing you where your natural daylight is being utilized to reduce your energy demand inside. Now, what are the systems that you can use? Glazing with selective coatings, right? So that the glare is cut out and the light is allowed to come inside. Certain color films are there. Certain colors are more soothing to the eye. So the non-soothing part of the light is cut out. Reflectors that deflect light into the depth of the room. Sometimes, say supposing this is a very large, long hall, and the light, this side is not available for your light inside. This side is also a building. You got a shorter side which is open towards you, so that light will not be enough. So there are reflectors which will deflect the light into the deeper parts, like the prism. You're all aware of, in the school days we saw the prism. The prism will deflect the light into the deeper part. So the correct judicious placing of those prism type of reflectors on the light side will light up the unlighted parts. Microgrid system with high reflective coatings. There are a number of coatings all through inside. Those are highly reflective. You have a microgrid of them which will create and transmit light into the depth of the room. Prism systems, related to the first point that I said. Light diffusing glazing. The glazing that you're using outside should be able to diffuse the light and get inside. Now, please remember, none of these systems which I've listed out, they have initial cost. Yes, nothing comes in life which is free. But there is no recurring cost involved in this. No demand on the energy. Once you have installed these things, you have reduced your energy demand and consumption forever and ever. Glass louver system, simple. You have glass louvers which will reduce the glare. Holographic diffractive system. You've seen the holograms which says genuine part. So those kind of things have been used in the lighting industry also. Those thin coatings which will deflect the light into the interior. Now, thermal insulation systems. One of the most important things, next from light, is your thermal comfort. You cannot perform optimally in case you are feeling too hot or too cold. Our human system functions most optimally in a certain temperature range. So that temperature range you have to utilize and incorporate. So thermal insulation systems is something that I would like to share with you, the wrong concept and the right concept. You all understand the importance of the thermal insulation, but how do you go about the thermal insulation is something that you got to understand. Heat energy is present. You cannot ignore it. It is present in the atmosphere. Regulating thermal transmission in a facade or roof by using materials to reduce the heat loss through what? Think of heat, and there are three terms which come automatically to your mind from the school days: conduction, convection, and third one, radiation. These are the only three methods by which heat is transmitted. So we got to utilize each of these three things to control the movement of heat. If you cut out these things one by one, the heat will stop moving. Now you have a building during summer, heat is coming inside. You want to avoid that, and during winters, heat is trying to escape. You want to reduce that also. So this is giving you sort of a diagrammatic view of what is the component. I shall show you the same thing in the shape of a pie chart. These figures which are given are not sacrosanct. They are just for the purposes of understanding, but comparative based on some studies. You see this pie chart? When you talk of insulating a building, almost everybody talks of insulate my roof. 99.9% of the customers or the clients or whatever people, when they're talking of insulating their buildings, they're talking of heat insulation of the roofs. Now, if you look at this pie chart, the roof contributes only 20% of the heat ingress. What about the balance 80%? Your appliances, what you're using inside, are consuming nearly about 16%. Your duct leaks, 10%, duct gain, 12%, infiltration, 6%. And mind you, your windows are contributing 30% to your heat transmission. We are not paying any attention to this. Walls are contributing 6%. Now, I'm trying to, I like to share with you certain experiences when we go across to the clients and meet them. They're saying, I had an incident where the customer for whom we had done some heat insulation job for the roof, calling me up at about 2:30 in the afternoon, saying, Colonel Saab, jara aa sakte ho to aa jao. I went because customer is all important. And he said, standing in the lobby of his first floor, he said, can you feel the heat? I said, yes, it is hot. But he says, आपने फिर insulation का इस चीज का किया है. He says, now, I said, now if you come to think of that, firstly, you are feeling the heat more than me because you are coming out from your air-conditioned bedroom. I'm feeling comparatively lesser heat because I'm coming from the outside, heated atmosphere. So the comparatively relative temperature difference is different there. And secondly, mind you, the roof is contributing only 20%. What about the balance things? We have not controlled the balance things. A similar argument people say, I want to insulate my walls also. That for the sake of 6% heat ingress, you want to spend money. And mind you, walls, which walls are contributing to your heat? Your north-facing walls are not contributing because they are never exposed to sunlight. So your west and south-facing walls only are contributing to your heat ingress. So please be judicious to understand this. The aim of showing you this pie chart is only this, that you must understand what shall I control. If you will notice, if you have not noticed, please try to notice now when the summer comes. When it is the afternoon, just switch off the lights, pull your curtains across. I mean, stop the outside light from coming inside, have heavy curtains so that the room becomes more or less on the darker side. When you switch off your lights, you will feel comparatively cooler. Right? So you got to understand what is affecting. Nothing. You have not switched on the AC. You have not switched on anything, but only doing shutting off that light and shutting off, only eliminating light from your environment, the temperature comes down. You got to understand the behavior of heat. Right? This thing understood, please. So, in a well-insulated building, during winters, you are trying to prevent the heat from going inside, outside, and during summers, you are trying to prevent the heat from coming inside. That is the aim. Now, I'll try to share with you from the roof, how does the approach towards insulating a building roof affects. This is the top of the building. you have the solar radiation coming and attacking it. The heat absorbed by the surface temperature, not the atmospheric temperature. Please don't confuse it with the atmospheric temperature. The atmospheric temperature may be in the region of 45 to 50 degrees. But the surface temperature becomes nearly about 70 to 80 degrees. Am I right? So this surface temperature, this is the thing which is affecting you. This is transmitted towards the inside of the building. You have that heat ingress getting inside, right? This is the system of heat affecting your building. There is a new approach which has been, you all heard of LEEDs, leadership in energy efficiency design, efficient design, GRIHA and other things which are now the green building concepts. A new approach towards the insulation of roofs called the cool roof approach has been developed. And this is the thing which you have to follow now. Previously, we were trying to use only prevent trapping of the heat. Now we are not talking of trapping of the heat. The cool roof approach, this is something that you got to understand in principle. Cool roof is one which exhibits combination of high reflectivity and high emissivity. Reflectivity is what? Reflecting the thing back. Emissivity is what? Whatever heat is inside, it should be able to be lost. Now, the winter clothing that we wear, what are they doing? They are trapping the heat or cold from getting inside. Right? But you talk of on the higher plane, the spaceships, they have a very highly reflective exterior, so that the heat or cold, whichever it is affecting them, gets reflected back. Whatever gets reflected back is prevented from getting inside. Okay. So, but then something has got inside also. That should also be able to be lost. If I'm wearing this pullover, it is a two-way process. It is preventing cold from affecting me. At the same time, my body temperature, it is preventing. So if the same thing I'm wearing during summers, I start feeling hot, because it is not permitting the thing to get lost. So this is what the cool roof approach is trying to achieve. You understood the importance, the difference. So that is what insulation versus cool roof approach is something that we got to understand. If that is understood, we proceed further. The traditional insulation, you have the porous insulation layers which retards the flow of heat. The top of the building, same thing. It goes inside. Heat input will become heat output, but in a staggered manner. This I shall give you an example by your own physical observation. During summers, ladies and gentlemen, inside your room, you do not feel the hottest in the afternoon. As the evening draws close, as the sun starts going down, you start feeling hot. Is that observation right or wrong? It is because in this afternoon, the sun is affecting your roof, but the heat has still not started coming inside. Towards the evening, the sun has heated up your roof so much that it starts throwing heat inside. And you'll particularly find at about bedtime, you feel the hottest. Because whatever heat was there in the roof has now come inside. And because of emissivity problem, whatever heat has come inside, you're not able to lose it. So both ways, it is harming you and affecting you. This point, you all agree with me or you do not agree with me? Right, I'm happy. Now the cool roof approach. The cool roof approach, the same thing. The heat is, solar radiation is hitting your roof, but then it is getting reflected back. During olden times, people used to do whitewash, lime wash on top of the roofs. Of course, it used to get washed off after the rain. But then, so long as it was there, it was reflecting back something back into the atmosphere. So that much of heat, whatever portion X which gets reflected back, is saved from getting inside. What you are wanting is that lesser amount of heat should go inside. So reject heat absorption by reflection, emission, and low conductivity. So low conductivity you are trying to provide that in any case. But then reflection and emission, these are the two new aspects which have come inside. So inside what you will have, heat will go inside, but then much reduced in quantity. So that much less of cooling effort will be required. Point understood? Right. So this is the same thing given in a photographic or a diagrammatic form. Heat is reflected. Now, related to this, I'm trying to give you as many practical parallels as possible. You find that the overall temperature of the universe is getting higher, right? The temperature, the glaciers are melting because of the temperature, the global warming. It has become a universal phenomenon which is being accepted all over, and that is why at the international level all the people are trying to reduce the carbon emissions. There are so many things that are happening at the international level. Now I will tell you, there is something called the heat island effect. Heat islands, whatever heat. Now somebody asked me during one of such lectures that when you are reflecting heat back into the atmosphere, you're heating up the atmosphere. No. Ladies and gentlemen, you're not heating up the atmosphere. By providing that heat reflecting back into the atmosphere, you are not created any heat extra, right? That extra heat that is getting back into the atmosphere is the same heat that you received. Whatever you received, you are giving it back. But in the process of your older form, where 70 degrees, your atmospheric temperature was 50 degrees, your surface temperature was 70 degrees. that 70 degrees is definitely going to heat up the atmosphere, but locally, not universally. So islands are going to be created. That local temperature rises in certain places, and those islands will be created where? In the built-up areas. You go to the countryside, during the same afternoon, the countryside is cooler than the urban built-up areas, because the countryside does not have paved areas. So the atmosphere is affected only by the heat of the universe, the sun. Whereas the urban built-up areas, they are reflecting heat which is of the heated surface. So heat islands are created on top, locally, depending upon where you are. This is the reason, ladies and gentlemen, I ask a very, very frequent question whenever I take this topic. When have you last seen the sparrow? The small chidiya, ordinary chidiya. Apart from your nursery textbooks, I haven't seen for years. Have you all seen? When have you last seen the crow? During our olden times, crow was a part of our normal routine. When the crow used to make a sound, कौवा आवाज करता था तो लोग बोलते थे कोई मेहमान आने वाला है. That was a part of our normal day-to-day living. आजकल मेहमान भी आने बंद हो गए और कौवा भी बोलना बंद हो गया. ठीक है? Where have these crows and where have these sparrows gone? They have shifted themselves away to places which were more conducive to their living, because of they are still available in your countryside. You go to the villages, those birds are still there, but they have left the urban areas. Our ecology is getting disturbed. And mind you, everything that God has, whether you say use that word God or whether you say use that word nature, everything that has been created with a purpose. Nothing has been just been created for the heck of it. Even the snake has got a purpose in the universal overall, apart from the religious aspect. Forget about the religious aspect. There was an article that I read that if you had to eliminate the honeybees which affect us the least, if we have got any memories of honeybees, is a bad one, that is a honeybee stings you and your body becomes swollen. But there was a study which said if all honeybees were eliminated from this world, the world will come to an end within 2 years. Because now I am not a biologist or something, but this was an authentic study. Means some disturbance of the overall ecological balance will take place. They say, save the tiger. How can you save the tiger? You are destroying the habitat of the tiger. You cannot go to the zoo and create an atmosphere and an environment in which that lion is supposed to survive. He cannot live himself in an air-conditioned environment. He has to live in the natural habitat. So you're destroying his environment. That is how the whole thing is getting disturbed. Ladies and gentlemen, the birds, you heard about the migratory birds? They fly across continents and spend that particular season in the area which suits their living, because they do not have air-conditioned houses. So we are spoiling, we are destroying the natural habitat. We've got to do something to prevent and preserve our natural habitat. So this is something which is very, very important. And insulation systems and reduction in the heat demand are very, very important. The traditional insulation systems, I'm giving a comparison of the two. The traditional insulation system, your thermocol, your blankets, your warm clothing, they are all as heat trappers. They can only trap the heat. They can only retard the flow of heat. Whereas the cool roof insulation rejects the heat absorption by the surface. The traditional insulation systems, they tackle heat transfer by only conduction. Whereas the other thing, you are doing conduction and radiation both. So it is when the two principles are being utilized, convection, of course, by convection is not possible. It's not heat. There are three modes of transmission. Why convection is difficult? Because convection by and large takes place in the case of liquids. So if there is a liquid medium involved inside, the convection will also. But when we are talking of buildings, we are talking of only radiation. The traditional systems are good for mechanically heated buildings. Like you have a factory where you got a furnace, you got machinery running, where internal heat is being produced. There you definitely need heat trapping so that heat does not escape. Good for preventing heat gain in the buildings need of the tropics. So these are broadly the differences between these two systems. This is showing you a small sample of the heat reflective coatings applied on the surface. This is a small building here in Chandigarh itself, where after everything, a coating, just like when I said you could do simple lime wash. But simple lime wash has got certain strong limitations. So this is basically a white colored coating, which will reflect heat into the atmosphere because of certain formulation and other things that have been formed over there. Polymers have been added to become stronger. So during the afternoon, you can't look at this because so much of reflection and glare is produced. And I have done a sample here itself in Chandigarh, close by, where I can get it observed. The occupants are saying, yes, there is a distinct fall in the summer temperatures. Winters, it does not affect you because it is allowing it to emissivity. So this is a very simple system. The only limitation is that it can be used, these things, coatings can be used for non-approachable, because after all, this is a surface coating and movement on top of this. But ladies and gentlemen, my own humble observation is almost 90% of our roofs today are not approachable, because we are hardly utilizing our roofs. The roofs are utilized only for dumping junk material. Am I right, ladies and gentlemen? I may be making a very wild statement, but this is the fact. There were times during our younger days when you used to go and sleep on the roofs during summers. But nowadays, nobody. If there are 3 occupants in a house, 3 have got an independent bedroom, and each one of them is separately air conditioned. One of those days when there used to be a single room air conditioner and the whole family used to flock into that. Right? So your roofs by and large are all unapproachable. Yes, there are some sit-outs which are extending out from your room, which have got some tiled floorings, where you want to sit out during some time, you want to have your evening or a morning cup of tea, you just take your chair outside and sit down. There it cannot be used. But for those surfaces, you have got insulating tiles which are available, which can be used, which are serving more or less the same purpose. Now coming down to natural ventilation. Ladies and gentlemen, sun, wind have been there from time immemorial. It is not that these are things of current occurrence. The deserts have always been hot, and they have always been very cold during winters. But people have survived in those places. How? Because they utilize the natural principles of ventilation. I'll share with you some of those aspects. Natural air exchange. Now this is inlets and outlets. I'm all relating myself to the building skin. Air hygiene. You go to a room which has got no outlets, which are all, you lock up a room for a month and come back and open it, you feel that stale smell. So what do you do? First thing, open it up, open the doors and windows, so that natural ventilation. So air hygiene is very important, again affected by the skin. Correct amount of ventilation, that is for you to control. Minimizing heat loss. You see the example, I'm just a line diagram, it says cross ventilation, very important. If the ventilation is not able to go across, it will not ventilate. It will need some forced ventilation. I have myself went and stayed in buildings in deep deserts where we did not need the requirement of a fan during summer. It's just because of proper use of ventilation. Olden times, it was a matter of force. People were forced to use, and they were using all these ventilation techniques. The wind enters, cold wind enters from, because cold is always entering from the lower side, and when it comes inside, it gets heated up, and it will go out from the upper end. So you got to locate your inlets and outlets. Previously, you used to have ventilators. Now ventilators are all gone. The architects say they are not good because And I agree with them because nothing happens except that the pigeons, they go and start staying there. So this is example of ventilation. In plan, cross ventilation, same thing. You could have a flue. You used to have chimneys earlier. People thought that chimneys are meant for burning firewood. Yes, during winters. But during summers also, they were performing a function of providing cross ventilation. Understood? Natural ventilation is a passive strategy. What is the difference between passive and active strategy? Passive is something you do not need anything external. Active means if you are employing an exhaust fan along with it. So the passive strategies coupled with active strategies can become much more effective. You go to industrial buildings, you have exhaust fans on the roof, air extractors. So there, because passive means are not going to be enough, so air extractors are utilized to aid that movement of air. Different this thing. You find air coming from inside, the cool air, and naturally when it comes inside, it gets heated up and gets out. The same thing, positive and negative, cool, warm, fresh air, depending upon what is the temperature outside and what is the temperature inside. Air movement takes place. This can be aided with the help of some active components of exhaust fans. This is an interesting example of modern buildings, wherein you have the direction placed in such a manner where the wind comes from. You follow the arrows and you will find in the windward direction. Now, ladies and gentlemen, wind does not flow arbitrarily. Every region has got the wind flow direction. It is not that कि कभी हवा इधर से आएगी, कभी वहां से आएगी, कभी वहां से आएगी. So based on those directions, you got to place your openings into the building and outside the building, getting outside. So proper judicious use of your inlets and outlets to the building are going to affect your natural ventilation. Then you have a multi-storied building on the right, wherein that kind of a thing, if it was not possible, what the architect has done beautifully, provided a central chimney sort of a thing inside without utilizing or harming any major space, providing inlets into the thing. The heated up air will get into the chimney and the warm air will go out. So this will, without using any forced ventilation, this is creating that ventilation inside your multi-storied building also. It's only the thought process. This is only giving you some examples, just 2 examples. With proper imagination and proper use, you should understand that this is very important today. Why this has become very important? Because drastic changes in the energy sector. You all have seen it in recent times. Diminishing availability of fossil fuels. Why the importance? Because fossil fuels are not going to last forever. Burning of coal, oil, and gas presents environmental hazards. the realization of the vast potential of the building skin. Now, I have by and large covered various aspects of the building skin. They may be costing anything, but there is no maintenance cost involved with this. One-time effort and whole lifetime of savings. Energy saved is the energy produced. This is what is the whole aim of the whole exercise. What we want to do, we have to have highly functional buildings, support creation of comfort, reduce energy demand, cater for combination of envelopes, achieve desired functional requirements. There are rapid development of new materials. This is just a tip of the iceberg what I've shared with you. If you search the net, you'll find hundreds and hundreds of options. Sky is the limit. You can do improvement on your existing buildings also. It's not that the new buildings only can be done. You can have handicapped ramps, you can have provide those sun projections, you can provide windows, new roof structure. There are so many new things can be added to the new building, old buildings also. Now, how do you, this is finally I'll share with you the process of how do we go about as a part of the planning. It's just a flow chart. It's summarizing what we have done. Building type, building geometry, and building location. These are the basic three inputs that you have to start with. Thereafter, this will lead you into the wall, the glazing, and the roof. The skin comprises of these three things: wall, non-cavity or cavity, masonry cavity wall, curtained wall, or framed wall. Under the glazing, simple glazing, double glazing, or triple glazing, quadruple glazing, depending upon what is the type of protection you want. Roof, low pitch roof, high pitch wooden roof, metallic roof, and concrete roof. So various categorizations that we. I mean, this is how you go about the flow chart as to how you decide what is to be used where. This will take you into, now the glazing part finishes there because there are nothing more to be considered. It is only the cost and the availability and what you want to do. Wall layers, cladding, air cavity, panel, coating, sheeting, wall insulation, air vapor barrier, structure, and the finish. There are various things that you have to consider as far as the walls are concerned. For the roof, exterior face, then you have to consider the waterproofing aspect as to the coat, whether it is going to be a coating or a sheeting, roof insulation, water or vapor barrier, roof depth, roof framing, and finish. These are the aspects that you will consider for the roof layers. These will come down and make you form the generic layers. What is the difference between, what do you mean by generic layers? Means the brands are not involved as to what is the type of generic formulation. What is the cladding, whether you want to have timber cladding, you want to have stone cladding, cavity, panel, coating, sheeting, all the generic formulation for these various things. Means whether to be stone, whether to be plywood, whether to be aluminium, I mean those things without using the names for the brands that are used, right? Generic means, you know the difference between generic and branded. Aajkal bahut, on the medical side, these things are being used. So the doctors are supposed to prescribe paracetamol and not crocin. That is what I'm trying to convey. This will lead you to the building materials as to what are the building thing. You require this much density, you want this much thickness, thermal resistance, vapor resistance, and specific heat. Ladies and gentlemen, the potentials are vast. It is only the question of start thinking that way. It has to become a part of our psyche, a part of our normal behavior. Like when you open a tap to wash your hands, there are two ways. One is to allow it to keep running. The other one is you wet your hands, close the tap. Apply your soap, rub your hands, and then open the tap and then wash. काम तो आपने हाथ धोने का ही करना था. But in that process, while water was not required, you stopped the wastage of its running. You're sitting in a room, you are wanting to go out, switch off those lights, takes no effort. Go to the other room, do your job, when you come back, switch on the light again, requires hardly any effort. Is this change of psychology? You got to develop that change of psychology. You got to develop that thinking process that this, my children's children have also got to survive on the same thing. You cannot keep everything for yourself and fritter away everything. So that is what is more important. Ladies and gentlemen, the human brain is very versatile. Don't ever think कि पेट्रोलियम रिसोर्सेज खत्म हो जाएंगे तो गाड़ियां चलनी बंद हो जाएंगी. No. Electrical vehicles have already come in. Petrol is being formed out of leaves. Even water is being used as a source of energy, right? So things will come. Alternative sources of power will come. But you got to please remember that the sources are not unlimited. And you got to use your ingenuity to use those things in the most judicious manner. That's all I wanted to share with you. If you have any questions, I shall be more than happy to answer.
Hello. Hello, sir. Hello, sir.
Yes, please. Hello.
Hello, sir. My name is Kushal. I'm from Afghanistan. I'm a student of third year in IC University.
Okay, please.
Sir, actually, I have a question regarding green building.
Fine.
My question is this, sir, that how will green building improve level of performance in our homes?
This is a very, very initial question. I think I think in your own house, if you listen through all that I said, you can use those principles to whatever extent you can, because I really cannot give you any idea as to what in your particular house I can suggest. But then the principles and the guidelines I have tried to highlight all through. It's a very, pardon me for saying that, it's a vague question. Is there any other person who has any, or maybe somebody from, anybody here?
Hello, sir. Good afternoon, sir. Sir, I have a question regarding best insulation material, sir. Which one is the best insulation material for roof insulation? Are you listening, sir? Hello.
My friend, insulating material, I have already tried to tell you the difference between two approaches. The two approaches, one is of the traditional insulating materials. Brands are inconsequential. We cannot be trying to talk of brands, but the approach as far as the building materials are concerned, we have to go in for a change of thinking in terms of the cool roof approach and not the normal traditional approach. So long as that point is understood, the branding is at a too initial stage to tell you as to which is the best material. You see, now for example, insulating materials, when you're talking of thermos flasks, if you go to the market to look for the traditional vacuum flask, it is just not available. The vacuum flask we used to have an inside lining of glass vacuum inside. Today you go and try to search for it, it is not available. It is the thermosteel systems which have come. So these things are different. The question is of what is, as far as the building materials are concerned, we are concerned with the cool roof approach and not the traditional roof approach.
Thank you, sir. Thank you.
इधर बैठ जाओ उधर बैठ जाओ
Thank you, ladies and gentlemen.
ये आएंगे
कोई आपको पहले आएगा
सर कैमरा वायर सर कमरे हो गया सामने लिखा है what is clear बेटा है वो भी नहीं अभी क्या आपको पूछना चाहिए था ना एक बार नहीं ऐसे थोड़ी चलता है
बिकॉज ये फिर आपका तो सिलेबस के पॉइंट ऑफ व्यू से भी टॉपिक है. So good afternoon and participants at all the centers in our studio also. I welcome you back for this afternoon session, and we have with us Dr. Ashok Sharma, who is the Chief Executive of Clean Tech International Foundation. He is former Member Secretary of Himachal Pollution Control Board and has been working in the area of clean technologies, sustainable development, apart from carrying out many R&D activities. He is adjunct faculty in this institute also. Along with he is the chairman of Center for Clean Technology and Sustainable Development, which is again have been established in Greater Chandigarh. This particular topic and on infrastructure sustainable development, sustainable infrastructure development along with eco materials will be the subject of issue for this afternoon session. So I welcome you, sir, for this session and request you to kindly continue.
Thank you. So good afternoon, all of you. And today we are going to discuss a very important subject, that is sustainable infrastructure development. As you can see right in front of you, the matrix of sustainable development, the sustainable systems and sustainable infrastructure, they originate from the same concept. So let's start with what is sustainable development defined formally. So sustainable development is generally defined as development which meets the needs of the present without compromising the ability of future generations to meet their own needs. It's very simple for us to raise our standard of life and to meet our increasing requirements, to draw upon the resources that are available to us and keep on drawing. You want more electricity? If you're able to pay, you can buy more electricity. You want more materials, you can mine more materials, and so on. But all the materials that are at our command, they are all exhaustible. If you keep on using petroleum, the petroleum resources will deplete one day. So it's very important to consider that if we so ruthlessly destroy forest, so ruthlessly undertake mining for our material needs, use petroleum resources so ruthlessly that there's nothing left for the future generation, their lives will be miserable. As such, it is estimated that by the year 2050, the world's energy resources would have exhausted completely, which means today we are in 2017, and in 2050, there will be no energy to meet our requirements. All the petroleum stocks would have depleted, the entire coal deposits would have been consumed by them, and we have nothing to bank upon. Why do you come this side? Really nice to see you. What? So what do we do in 2050? This likelihood of total chaos. No one would have any energy left. You can't find any more petroleum, you can't find any more wood, you cannot find any more coal, you cannot find any more electricity. So what to do? When I say electricity, thermal electricity. Hydropower will still remain. And that is why we call hydropower an alternative renewable energy resource. So at that time, we would only be left with one choice, that is renewable energy resources. And what are those renewable energy resources? It can be hydropower, it can be solar energy. Sorry, somebody said? Wind energy, of course, yes. And all these forms of alternative energy, which come from the renewable resources, would be the only thing to bank upon. And if we harness the entire available renewable energy in the world, it is just enough to meet 10% of the requirement, which is going to be there in the year 2050. So it is a very, very dismal picture. People would be forced to ration energy. Many would be deprived of energy sources. And the life is definitely going to be very, very miserable. So what do you do under such a situation? There are only two options. It is today only we start thinking the scenario of 2050 and start conserving all resources, and think in terms of greater and greater utilization of renewable resources or alternative resources. Anybody who can think anything in addition to that? What do we do in 2050 to meet our requirement? Any suggestion? These people are late, maybe from this side. You are in 2050. Your petroleum resources are depleted. Your coal stocks are gone, converted into ash. There is no forest left. You consumed every gram of wood that you could find. Now, how do you go about it? What is that? Your natural resources, which are source of energy, are depleted in the year 2050. What form? Ash cannot be converted back into coal. Smoke cannot be converted back into petroleum. Right? So, wood is burnt, coal is burnt, petroleum stocks are zero. I'm talking of 2050. What do you do then? You can't convert them into another form of energy. Okay, I'll take it. Right? That was the question of converting one form of energy into another form. Yes, well taken. That energy stands dissipated. I used it for light. I cannot store light. I used it for heat. I cannot store it. I converted petroleum into smoke. I cannot recover it. I converted coal into ash, wood into ash. I cannot reconstitute wood and coal. So you are looking at alternative sources. Because you came late, I was just talking to them that alternative resources, particularly the renewable resources, are definitely at our command. And all the renewable resources like the biomass, which we may be still growing, the solar energy, the wind energy, the hydropower energy, they will all be able to merely meet 10% of our energy requirement in the year 2050, which means 90% shortfall in resources. Today we are enjoying a luxurious hot water bath. Well, no, you won't be able to afford it. We do air conditioning and heating, cooling like anybody's business, lavishly. No, you'll not be able to do it. Which means you're going back to the primitive era where people lived with minimal resources. So rather than subjecting your next generation to that kind of scenario, one major initiative is start thinking today in terms of conserving the resources. Maybe if they are going to deplete by 2050, we plan in a manner that, okay, to up to 2090, if this situation doesn't come, we're postponing it. But another thing is growth of the alternative energy sector. Where he mentioned uranium can be converted to electricity. Nothing new. In fact, it's been done already and it's being discarded in the developed world because of the environmental consequences. So this form of energy has been tried, is to be discouraged. Let there not be a situation that we need to rely upon that. And particularly in the context of developing countries, it's a dangerous technology. Reason that we are not tuned to safety requirements of the systems. That's very important. If there can be an accident in Chernobyl, there can be an accident in Japan. Well, it's very likely here, much more likely. So the environmentalists have been always agitating against the atomic energy, and particularly if it is fission based. But then there is an alternative, which is called the fusion technology. I refer to the American Congress 2009, where there was a formal proposal put by one of the senators. You know, we have the members of parliament in India. So one of them, similar scenario in US, he put a one-page note stating this scenario of 2050 and saying that it will be absolute chaos unless we prepared ourselves to meet up the gap. And he said, one spacecraft of helium-3 brought from the moon can meet the energy requirements of the United States of America for full 1 year at a cost equivalent of $8 per barrel of oil. The petroleum crude is around $50 per barrel. And he discovered that if I bring helium, helium is very rare in the Earth's environment. So he imagined that if we bring one spacecraft from moon and apply the fusion technology to convert it into electricity, that small amount could be, it is such a concentrated form of energy, it could meet the energy requirements of the United States. It doesn't care for the rest of the world. We are second-rate citizens of the global community. But for America, yes, that was a good solution. That's why they've been working on the fusion technology past 15 years. And they're discarding the nuclear energy, which they're trying to throw into third world countries, including India, almost forcing us to buy it. So we need to keep on continuously thinking and imagining solutions. When we say solar energy, in India it's very potential, because the rate of insolation here is far higher than the Western world. So if there can be an 800 megawatt solar thermal power project in California, we should easily think of gigawatts of electricity generated by a solar thermal. Normally, when we talk of solar energy, at the back of our mind is always solar photovoltaic. Do you agree with me? If we say we'll have solar system, except for some water heating systems on rooftop, which is thermal, we always think of solar photovoltaic, which means the solar energy is converted into DC current and which can be utilized for our lighting and other energy requirements. But when I say solar thermal, it means that we use this solar energy to raise steam and then run a turbine like any coal based thermal power project or gas based thermal power project, and we generate electricity on a mega scale. This is also a solution. No, this is the supply side. How can I substitute the gap in the availability of energy? But more important is the demand side management. If I'm consuming non-renewable energy, switching over to renewable energy is a very good option. If I'm guzzling energy, consuming maybe 50% energy is a very good option. We are all talking in this room with so many lights on. If we open these curtains, we could get enough light. Our energy requirement would be cut down. We do talk about it, but never do it. So that's one thing where the culture for energy conservation has to come. It has to come in our thinking process. So at home, when you're going out, you must have a habit of switching off something, which generally doesn't happen. Your TV is on and you are moving outside. It happens every day. Your geyser is on 24 hours, using it for bath in the morning. The rest of the time, it keeps heating the globe. So these are things which you have to consider. And most important is designing a building. Now here is a building where you could receive the natural light. But there are many buildings which are not designed this way. So there is no option but have all full lights on. And that brings us to the subject of sustainable development. Particular component is sustainable buildings. If the building is designed in a manner that it consumes less energy, or ideally it consumes zero energy. When I say zero energy, it's difficult to comprehend it, but if I'm receiving sunlight from above, converting into photovoltaic energy, and these lights are running on that, it is a zero energy system. Whatever I get from the sun, I'm using it, meeting my own requirement out of it. So for sustainable development, the general principle is whether it is water or energy or materials, they are managed in such manner. We manage the demand, we also manage the supply in such a manner that the resources are not depleted and the future generation receives something from us, or we pass on the earth to them the way we received it, not worse than what we received. Right? So that is, in simple words, one would define sustainable development as. So how do we restart it? Control? Anybody? You did it. How can we? Okay, it's there already. Now, implications of sustainable infrastructure. We are not compromising on quality of life, right? We must have first of all growth, but the growth has to be sustainable. I'm not saying that you stop eating, so the food resources will remain intact. No, we need to consume in a manner that our production is more than consumption. So we must be able to meet our basic needs, improve our quality of life, and still ensure that we leave behind enough for the future generation. And where all the sustainable development of infrastructure comes into play. Development of cities and buildings, that's the first one. Most of the resources you consume is making of roads, making of civic infrastructure, drains, sewage system, buildings, energy generation, distribution, transmission. Then municipal waste disposal. It's very important. And here, there's a very, very important resource when you are disposing the municipal waste. It could be a very good source of energy by itself. In Japan, nearly 70% of the energy requirement is met by incineration of garbage. The garbage is burnt, there's a lot of heat generated, you raise steam, make electricity, and supply to the community. Though there is a very, very strong threat of air emissions when you are incinerating garbage, you can pollute the air very heavily. So that is where the technological skills come into play. They minimize pollution, convert the entire garbage into electricity. For India, we have a still better option because we have a lot of material which goes waste in the farm, and it can be used to generate biogas, which again gets converted into energy, whether it is in the form of gas that is burnt or the power which is generated. So this is another opportunity for converting waste into energy. Then sustainable mobility is very important. We have tremendous amount of air pollution. You see every day Supreme Court intervening into Delhi's transport system because the environment there is now such that going out of your house is dangerous because of the air emissions that you're taking in. So we've been talking about sustainable mobility. There are a variety of methods. One of them is electrical mobility. So you have a vehicle which runs on electricity. It doesn't generate any air emission, and the environment is kept clean. And there are many other options which we can talk a little later. And last is civil aviation. The aircraft gives out for one landing, it gives out air emissions equivalent of almost 4,000 vehicles. It is a very huge source of air pollution. So that's the aviation sector has also to be looked into very carefully. And in some of the countries, smaller aircrafts, they operate on solar energy. These are new ideas which are coming. People are trying to translate them into reality ultimately the objective is how to conserve energy, maintaining the pace of development, yet protect the future generation from hardship. Somebody said anything? Okay. If you have any questions, you can stop me. So how we do that? First thing is, in the infrastructure building, what we use is materials, necessarily. You make a road, you use materials. You make a building, you use materials. In making of those materials, a lot of energy is required. A lot of emission is caused. A lot of resources are used. So the making of the materials should also be sustainable. That's very important. We make bricks. You can always say that they're made from the clay, which is abundantly available, is not going to deplete in near future. But then so much of energy you are spending in baking that clay to make a red brick. So much of environmental damage is being done. So much of energy is being consumed. So think of an alternative which consumes lower energy. Maybe the clay could be mixed with a binder that by itself is a stable brick. Many of you might have seen the fly ash bricks. So fly ash is a waste which cannot be thrown around, dumped everywhere. So if you convert it into bricks, you are utilizing waste. It's a step towards sustainability. You may compact them, put them with a binder, you don't have to bake them. They have the same compressive strength as the clay brick has. So if you look at the entire infrastructure, like coming at around Zirakpur and those large buildings, they have been forced to use fly ash bricks. The regulatory authorities thought of putting as a condition that we allow you to make houses if you use fly ash bricks. This is sustainability. But then you are a rich man, you don't think that this fly ash brick is a good material. You want something very fancy, you want tiles. Then you are bound to buy materials which are not eco-friendly. But as a sensitive citizen, you have certain amount of commitment to environment. You think that I can make a good looking stuff, but I must buy something which is eco-friendly. So that gives birth to a new concept. Let there be eco-friendly tiles. The tiles should also not consume that kind of energy. So there is a whole set of eco materials which comes into play, either by choice or by regulation. First thing is that you want to do good, so you buy eco materials. But second thing is you don't want to do it, but the law requires you to do it. Otherwise you can't make a house. So then again you will think in terms of eco materials. Now, what are those eco materials? Now, simple language, they are those materials which generate lowest environmental impact during their total life cycle with the following essentials. You can read there. Do not use scarce or hazardous raw materials. Functional ability to clean and conserve environment. Third is low environmental impact during manufacture. They are not consuming energy in a big way. They are not giving out. So many of you use the marble flooring. How it is done is that you take a rock, you slice it, and when you're slicing it, you're generating a lot of waste which flows into these drains, choking them around. It's not an eco-friendly method. But some of them, they don't allow that powder when they cut it. They don't allow it to go into waste. Use a binder, make artificial tiles, moldings, wash basins, even bathtubs. That's again sustainable material management. The performance should not be compromised. The life cycle must be long. Even if you used a material which is eco-friendly, but you need to replace it every third year, then you are consuming more and more resources. So the durability, that is the life cycle, also is required to be long. If you are using a plastic bag, carry pack is thin, it can be used once or twice, it will go into the waste. But if you are carrying a basket or a thick bag, which is used 200 times before you discarded it, you are reducing the impact on environment. Then it should be easy to recycle. So when I say, a carry pack, well, you might think it can be recycled very easily. But how about a building? Can you recycle this building? No. No. Can you recycle a building? Anybody? Anyone who says yes? No, many people have said yes. No. Few of the materials. Okay. What are those few materials? All right. All right. These panels, not the structural material. Okay. Now, one of the biggest. Sorry. Now you see, it brings us back to the subject of eco materials. What are eco materials? Which could be recycled easily. Like if there are plastics, they can be recycled. If there is steel, it can always be recycled. Steel will go for remelting. You will again recycle it. What cannot be recycled will constitute debris. Debris. You break the building, you have the concrete lumps, you have many things which are crushed and put in a dumping yard. Now that is a very, very important material. If you crush those lumps and again process them into concrete, it is possible. And merely doing that, your building recycling becomes to the order of almost above 70%. So the recycling of construction material and debris is a very, very important subject when we are talking about sustainability. And you use such materials which are more and more easy to recycle, right? So this is a very, very important intervention. So when I say sustainable building, A sustainable building is one which, when pulled down, can be recycled to a great extent. May not be 100%, maybe 80%, 70% onwards, anything. So it is a sustainable building. But that is a sustainable building when you're considering the entire life cycle and recycling. But during its life also, the building has to be sustainable. So when there is a building, it consumes what? It consumes lighting, which is energy. It consumes heating, cooling, air conditioning, again energy. Right? So if you put a lamination during summer, the sun gives you lower heat, your air conditioning cost is reduced. Or you put the blinds, your air conditioning cost is increased, is reduced. So by merely controlling these blinds, merely considering the paneling, you can reduce your heating and cooling cost very considerably. And so can you reduce your lighting by controlling the nature's lighting. Now, how do you do that? One is your building design. Another is the orientation of the building. A building which faces south, it gets the entire amount of solar energy. During winter, you will get sunlight right inside the building. From there, it will come up to here. You perhaps don't need heating. And during summer, it will stay at the doorstep because the sun goes above the building. So by simply orienting your buildings, all of you someday are going to make a house for yourself. Please consider it. It's very important. I have a house in Shimla, which is accurately south facing, and the front side is glazed, all glass. Back side there are no rooms, only services, staircase, kitchen, some laundry or service areas. So you have a row of rooms. And wherever you are sitting, you have full view of the nature. During the summer, the sunlight comes in front of your window, outside on the outside wall. And during winter, it touches this wall. So when I go there, I don't use any heating during the day. And since the house is made of stone, during the day it gets heated up, and at night it releases the heat inside. That's the traditional architecture. So I don't need much heating even at night. So in Chandigarh, people are shivering because you can't get sunlight. True. I don't know how many of you live in Chandigarh, but there's a lot of fog, so you don't get sufficient sunlight. So you're shivering. But there in Shimla, I may be in a shirt, enjoying sunbasking while I'm living in my house. That's the energy efficient building. Then on the rooftop, you have the solar panels. Normally what you do is you make a house, then you make a structure on top of it, then you fix up the solar panels. So you're putting a dead load on your roof. Instead that, since we have slopey roofs in the hills, so rather than using those sheets, use the panels. Don't make two roofs, make only one roof. So it can give you heat, it can give you the photovoltaic light, and the building can be self-sustainable. You may not need actually the outside energy for heating or cooling, or even for lighting, right? What we call a zero energy building. So the eco-materials have to be renewable, recyclable, non-toxic, non-hazardous, locally available. And secondary derivative means that from the existing materials, we are able to reconvert into usable material. Particularly wood is a very good example of that. And then they are ideally generated from waste. As I gave you an example of fly ash brick or a recycled concrete. This is what you do is use a polymer to crush the concrete. There will be small lumps, less than half an inch. Put them in a mold with a polymer. So the polymer is a binder, and it has become the lightweight insulation blocks for a building. And mind you, insulation is very, very important for a sustainable building. So during the summer, you're not getting heated up unduly. During winter, you're not too cold. So your heating and cooling cost accordingly goes down. Structure is light. In the event of an earthquake, it is very safe. So there are so many parameters which have to be looked into when you're talking of eco-materials. You can keep these objectives in mind when you're designing eco-materials. The strength must be high. The life must be long, because the replacement brings more pressure on resources. Low environmental impact we already talked about. And energy efficient manufacture and use. That's very important. Enhanced natural light and energy. That is a matter of architectural design. But again, as I said, in a roofing structure where you're using sheets, if you can use few of the sheets which are transparent, you get the advantage of sunlight inside. The material must provide high degree of insulation. This is just summing up what we discussed so far, and it should ensure total recyclability. This is an example of what we were just now talking. If you have this kind of solar tiles, which are just screwed on top and to go on placing one above the other. Have you any of you seen the slate roofing? What you do is keep one slate above that and then one above that. So they are overlapping and you go on screwing them. So same way, these solar tiles to your right, they are made on the same pattern, and they're very, very frequently used in the Far East countries, particularly Japan. So what they do is they make ceramic roofing tiles, which are very good, porcelain material. They are very fancy. They are very light, and they also generate power. And if you have heard of a company called Kyocera, there's a company by the name Kyocera. Kyocera is an international giant in the solar systems. Their actual name is Kyoto Ceramics. I lived for about 6 years in Japan, and their headquarters was very close to my house. They were ceramic manufacturers. They used to make ceramic knives. So one knife which is made of aluminum oxide You can use it all your life. You don't have to resharpen it. Normally, you have to sharpen a knife. But this is made of ceramic. And they were making also the ornamental ceramics, the very expensive type of ceramic ware. And finally, the roofing tiles. With the Kyoto architecture, the roofs are very ornamental. And they thought of it some 30 years back, that these tiles could be made solar. So it is an innovative idea which came, and they started making it. Eventually, those tiles became very popular. Everybody was buying solar tiles. And that's how Kyocera turned into a leader in the solar technology. Today, they are all over the globe making not ceramic, but other solar panels. This is how a building would look like when we use the solar materials. If you're having a shopping mall, you have one here, Elanta or something. If you had all the exterior, you have seen that they're thick glass. They're all made of glass. Now, in place of that glass, if he has solar panels, he would cut the light from going inside, heating up the structure. And it will also generate power in the process. So if you have a solar roof like this building, that panel should be south facing always. That's a principle. And that the entire building, it has solar panels spaced all over, you can see. So this is a sustainable building. It doesn't need an external supply of electricity. At night, you close down 8 o'clock, 9 o'clock, or 10 o'clock. Morning, you'll reopen. The whole day you have sun. And the energy you store is sufficient to last you till you closed your business. So if all buildings are made like this, you can imagine there should be no power shortage. And when people start using it at such a scale, the cost of solar products will also come down. This is how it happens in China. They have, lights which are hanging outside near a source. The whole day they keep gathering the sun. At night you switch them on. They are there for 4 hours. All your requirements are met. So even at a village level, you can have, I did not know, this was not planned, but I had those lights with me, I could have brought them. So we just, install it anywhere in the garden. So all day it will be catching sun. At night, you switch it on. These are some technical things which, when you get the material, you can go through. Yeah, please. No. Now, if I open these blinds, sunlight will come in, it will heat up, right? Now, if instead of these glasses, we had solar panel, it cuts the light there. Light will not pass through. And it converts it into electricity, right? With the electricity, you may be able to run even an air conditioner, right? That depends on the efficiency of the system. The objective is cut the heat. And I'll give you an example of German houses. That's where you have very little sun. So what they use is the solar curtains. There are small round solar cells which are stuck onto those curtains. They're beautiful designs. There's a tree, and instead of the leaves, there are solar cells, and those branches are actually the conductor for the current to pass on and collect at the base, and then they are stored. So when there is strong sunlight, you're partly getting light and sun, partly you are converting into. So if you want more sun, more light, you put off the blind. If you want more of light energy, put the curtain on. So this will depend upon your whether you're living in Shimla or you're living in, let's say, Delhi. Your use pattern will change. Because there I want to insulate against cold. Here I want to insulate against heat. So what you do is that when you're making a building, the architect will consider that you are not receiving much of sunlight inside. One way is to have fixed wall and small windows. You are losing flexibility. Another way is you have blinds. Put on the blinds when you don't need sunlight, and your air conditioning load is reduced. So it's not that solar panel will heat up. That is only the solar thermal. See, where there what happens is you have a black surface which catches the energy, heat energy from the sun. It is attached to copper pipes which contain water, passes through that, it heats up, collects into geyser. So you can use it for bathing. You don't use the electrical geyser, use a solar heater. So there are two different distinct type of solar energy: solar thermal, solar photovoltaic. Here we are talking of photovoltaic. When we were talking about this building, this is photovoltaic, not thermal, right? So we have, measure it generally in terms of energy performance index. That every square meter of the panel, it should have something like 200 to 400 kWh annual. Over a year, this gets you this so much of energy. So you need a large area. That large area is your roof. It could be panel, or your front walls, which could be paneled. Even not necessarily your window should be paneled. Your front wall can also be paneled, where you do the tiling, or sometimes you only paint. So you can have panels there also. That's why I showed you that picture. This you can go through at length, because if we start discussing these technical parameters, it will take a lot of time. But here are a few examples. This is one building in Mumbai, right? Now this is called an energy inefficient system. No protection from rain and sunshine. So it has to be artificially lit. It has to be air conditioned also. It increases the energy consumption very high. And average billing at that time when this building was surveyed was around 15 lakhs per month, which is very huge. But as against that, we have this kind of building which is to the left 100% glazed, right? And towards the right, This is a building which gets the maximum natural light. And finally, this is the building which won an award. This is called some Golden Eagle Award, which is given to the energy efficient buildings. So this is done jointly by Godrej and the Confederation of Indian Industry to make a demonstration of what an eco-friendly, sustainable building should be. I've been to this building, and by now technology has further improved, but in this building, you have a lot of rainwater harvesting. So all the requirement of water is met by that. The toilets are waterless, and all the rooms are lit up by the natural light. You have minimal internal lighting in the entire building. So that's how you plan, make a building, and while making a building, use materials which are going to be recyclable. So what are you achieving? You are not consuming heating load energy, you are not consuming air conditioning, cooling energy. You are not using electrical energy for lighting. You are recycling the harvested rainwater, putting it to maximum use. And all your materials which you used here, they are recyclable. So even when you pull down this building, at the same place, about 70% of the building will come up by reusing the material, 30% maybe coming from outside. On the whole, whatever I said was a concept. That's how we should think, that's how we should plan, because we have to conserve the resources for future generations and also make our own life comfortable by reducing the emission level, right? Orientation, I told you, is very, very important, so that you are getting the maximum from the solar resources. These are some of the technical aspects of architecture, how a building is planned. Particularly, you can have a look at this domestic solar water heating system. This is the kind of panel which you are talking. It gathers the heat, but then it heats up the water, not the room, right? When we are using the solar photovoltaic, we are using it for dual purpose, stopping the heat from coming in and also converting that energy into electrical energy. And there are such tiles and panels available which consume both. So these Kyocera tiles, which I was talking about, they are spaced in such a manner that they consume the heat energy of the sun as well as the photovoltaic energy, because they live in a cold region. So they use it for internal heating, and they also use it for getting the electricity. But if you are living in a hot zone, then you need a solar refrigeration system. So you are converting it into electricity, and the heat is being converted into. Have you ever heard of solar refrigeration systems? But are you aware of the refrigeration, what it means? What is the principle of refrigeration? You compress a gas, whatever gas. Freon is very efficient, but even if you compress normal air or any other thing, and then allow it to release. So when a gas is released, allowed to expand, it takes up energy for its expansion. from whatever is available next door, from the four walls of a container from which it is being so. It will chill the container. Sometimes if you have a gas cylinder, you just open it, keep it in outside, open it. The gas goes up and you'll see the ice encircles the cylinder. So whenever you are releasing a gas, it generates chill. Same principle. Today we use a compressor for first compressing the gas, then you allow it to go to an evaporator where it chills the system. So in the older days, what they used to do is take a gas, which is generally ammonia, heat it up. And when you heat up ammonia, that and allow it to evaporate, it chills the chamber. So when I was a child, we had a ammonia refrigerator where you used to light up a candle below it, heat it up. So when it evaporates, it creates the chill inside the chamber. So later on it was discarded because we had very efficient refrigeration system. But in the Western world, particularly in Sweden and also Denmark, they use the solar evaporation system for refrigeration. Why? Because when they have no sun, the average temperature is around 0 degree or 2 degree. So the cold storage is functioning. They use it for the storage of milk and milk products. And when there is sun, the solar refrigeration system starts working. So if you have a building in Delhi or Rajasthan, you should have a solar refrigeration system. Whereas if you had it in Shimla, you'll have heating system. But in both cases, the solar energy of sun is being used, which is free and abundant and renewable. It is not depleting like the petroleum resources. This is the principle of that. I was trying to show you the solar air conditioning. That you will pump it, store it in the chiller, then release it. And the building is cooled. From the chiller, you throw the air into the building. So you will have a large system, not like this small compact, the air conditioners. But the effect is that you are not using the electricity, you are using solar energy. Then in cold areas, you need solar passive. As I said that I have a building where you gather all the sun during the winter. The stones are heated up all the day, and that at night they are releasing energy. So this energy doesn't, this design of building does not let the solar energy go waste. The building is solar passive. Again, the same principle is shown, the south facing and close on the north. You have smaller windows on the northern side, you have big window on the south side. This is a system of ventilating. You get cold, fresh air as to air goes out. But this is not very much required in the Indian system. Now, this is another example I wanted to share with you. This is the solar lighting. You have a dish outside, solar, which catches the sunlight. From where you bring this. This is the optical fiber. Many of you we use it for their ornamental purpose. But the same thing, if I have this bunch coming from outside this building, bring it like a pipe supply and let it be hanging here. So I have sunlight lighting up this free of cost. So whenever there is sun outside, even if I have closed all the panels here, I can transport, because the quality of an optical fiber is you make it zigzag, the light also goes along with it. Normally what happens, light travels in straight line, but you want to supply light, optical fiber is the solution. In Japan, where I was working, there is a lake called Lake Biwa, the second largest lake in the world after the Lake Tanganyika. Lake Tanganyika is in Africa. That's the world's largest sweetwater lake. And the number 2 is Lake Biwa. And they invited me to visit and suggest some method of how to maintain the water quality of that lake. And their problem was that lake was very deep. And when the algae grows inside the lake, the sunlight doesn't reach the bottom of the lake. So the water quality at the bottom becomes bad. It is a dead water, has no oxygen. So I suggested to them that maybe you can have the solar dishes along the periphery of lake and carry this kind of lake and right up to the lake, bottom of the lake. Near the periphery, the depth is less. So if you take it to the bottom of the lake, the sunlight is transported via the fiber. It's very expensive. I could not have done it in India, but they did it immediately. And next time when I visited, there was a very big, public function there, demonstrating to people how the water quality has improved in the lake. But that was a source of drinking water for the entire community. So this is an innovative application of solar energy for lighting inside. Now this is a very interesting material, eco material. This is called aerogel. And what is this aerogel made of? Anything? It will work everywhere where it is. When if you go to Norway, for instance, Norway is called country of midnight sun. I have seen sunlight at 2:30 at night. Right? At 2:30 you can read a book. And at 9:30 or 10 while waiting for a train, I went to their solar shed and rested there for 1 hour waiting for it. It was absolutely warm. Because there's a 6 months long duration. The duration of the sun is very long, though the intensity is very low if we compare with ours. So they thrive upon this thing, insolation. Many of you might have seen United States, large buildings, which are all glass buildings, mega multi-story buildings, which are, which use glass panels. And actually speaking, they are not glass panels. They are sandwich glass. Same kind of glass as you have seen in these malls here, or the exterior. They have huge buildings which are totally made of glass, and very few people know that this is not glass, this is two glasses sandwiched together. And what is inside is this aerogel. I again missed it. There's a short timer on this. Yeah. This aerogel is what? This is simple silica, which comes from sand. This is silica which is hydrated and converted into a gel, which is 99.8% air. All right. Any doubts? You understand this? It's so light, fluffy. Inside 98% is air. Only 2% is materials. And this gel, if a 3 mm sheet is made, you keep it on your hand and put a welding torch, it will not allow it to damage your hand. It is such a great insulation material. And what is it made of? It is silica. The silica, the simple chemistry, this silica mixed with water is intensely agitated via ultrasonication, so it gets hydrated. So it will be something like silicon hydroxide, and it becomes very fluffy and very light. And what you have to do is then dry it. It's a very high technology. The drying is done by freeze drying. And this is the material. Keep as said here, a 500-gram block of this gel. On top of it, you can keep 500 kilograms of load. It will bear the load. The compressive strength is so high. And the insulation quality, I already told you. So it is put between the two glass panes, sandwiched. And those glass panes are used as a building material. They don't tell us. And we kept secret over years. The Americans, when they make anything commercial or a breakthrough technology, they don't allow it to leak out for decades. We all think that this is a beautiful glass building. It is an insulated building. Outside temperature is -15, -20. Inside you are very comfortable. Only the solar heat is good enough to keep you warm. So in a temperature of -15 to 30, you are warm enough because whatever little sunlight you got, it stays inside. Any doubts? The solar energy can penetrate this. It has two components. One is the ultraviolet rays and the infrared. So when the sun rays penetrate through the system, the heat can only come one way in. It doesn't go out. It keeps accumulating, right? And it's a very strong material. It doesn't allow the glass to wrinkle. So this is a very important eco material. We said this lighting. Before that, we talked of the tiles. It looks like a polystyrene, like you have the poly houses. It gives a very similar look. Very light, very strong, remarkable thermal insulation, good convective inhibitor, good conductive insulator, and a very good radiative insulator also. And it absorbs sound also. So making of a building is a very ideal material. Another form of this same aerogel, when compressed, you can use this. See, it is used as for insulating the pipes. During winter in the colder region where you have minus 15-degree temperature, the water would freeze inside the pipeline, or for that matter, any liquid flowing through any pipeline, it freezes. So this insulation will not let it happen. Different quality of gel. It can be used as these rolls, sheets, cut to size, application for the panels. This is the kind of the shed I told you. I waited for 1 hour in the train. It was like I was basking in the sun at 9:30 to 10:30 at night in Norway. Now, building fitted with translucent silica hydrogel panels. So that panel is made from silica hydrogel. It allows the light in, allows the heat in, and the panels on top, they're all made of gel. So this is just a picture of a demonstration. And the future developments, I use the word sky is the limit, because you start imagining a solution which may be as mad as possible. People may laugh at it. But what you imagine can be achieved. And nothing can be achieved unless you imagine. So don't limit yourself by saying, this is possible. No, it's not possible. Has to be possible. If I want to recycle, I will find a way to recycle. So the first thing is, don't go by what we are looking around. And all these things, they are an outcome of imagination. People have done. What time you finish? Have you overstretched? No. We have some time? Or like to go? Okay. Now you have any questions? I'm here. If you don't have any questions, say no. We don't have any questions. We can have a nice time.
I have a question.
Yes, please.
Sir, actually, my name is Kushal. I'm from Afghanistan. I'm the student of third year.
Actually, your name is Prashant?
Yes, sir. My name is Kushal and I'm from Afghanistan.
No, I thought it's actually Prashant, not otherwise. Okay. Prashant? Yes, yeah.
Yes, sir. What is the most eco-friendly packaging material?
What is the most?
What is the most eco-friendly packaging material?
Packaging material.
Yes, sir.
Okay, we were talking of sustainable infrastructure, not sustainable materials, but yeah, okay. No, this will depend upon what are you going to package. That's important. The best packaging material globally is, a banana peel. That's what people say. So one must know what is it that you seek to package. Accordingly, the material can be designed.
to mix the eco-friendly material, we can give an example like plastic. Plastic is a good eco-friendly material which we can use, for example, in packaging or any other.
You see, if you are talking of reparational plastic, right? Then biodegradable plastic is an obvious answer.
Okay, sir.
Biodegradable plastic is an answer. And what is biodegradable plastic? Then next is that question, right? A plastic which can be destroyed by the nature's bacteria when in soil within about 3 months is a biodegradable plastic, right? Give you an example. If you mix up the normal plastic with, let us say, starch, right? 50-50, all right? Then that packaging material, when discarded, at least 50% of it, that is starch, in 2 weeks will disappear. It will be fragmented into small particles of plastic. And next thing is, what is that plastic made of? Now, if that plastic is made of, let us say, lactates, which come from the milk processing waste, they are easily degradable. I don't think he is listening, but at least we can all share. There's a break in the system, it looks. So if you're using the starch and mix it with the plastic fragments because the starch will degrade. But it is not a degradable plastic. The plastic, instead of its original shape of a sheet or a lump, will take the form of small particles of plastic, but not still destroyed. The solution lies eventually in making of a biodegradable plastic, which comes from 2 sources. One is the lignin, and another is the milk whey. You see, the wastewater which comes from milk processing is a very good source because they are primarily lactates. So these are 2 materials which are currently proven, but many people are working on various forms of biodegradable plastics. And even building materials. Oh, are you able to?
Yes, sir. Yes, sir. Thank you so much, sir. I received my answer. Thank you so much, sir.
Good, good. Thank you. I'm very glad that you had it. Thank you.
Hello.
Yes.
Speaking from Social Engineering Department, Maharaja Agrawal University, Delhi. I wanted to ask this about aerogel material. This aerogel material is having high compressive strength. So why it cannot be put in concrete?
Say it again. Last line.
It has high compressive strength. Aerogel.
Okay. You see, concrete it will be a misuse of it. It is something which is transparent, or I would say translucent. It can be a very good paneling material, which provides a high degree of insulation, high degree of wall strength, and also it's very light in weight, right? So the best thing is to use it in as a paneling material. That will be cost effective also, and this will contribute to the energy efficiency of the building. For example, you are in a let's say cold zone, even at the South Pole. If you have a building made of aerogel, well, it will be warm, sustainable, and energy efficient.
Is this material being used anywhere in India?
There's a lot of echo. Please keep away from the microphone. I may be able to listen to you. Yes.
Sir, we are asking, is it in use in India? It is being used in India or not? In buildings.
Aerogels are not in use in India, and the US firms which are making these aerogels, they avoid Indian market, and they're meeting the requirement of the West only. But it's something which is not very difficult to make. There are institutes within India who are working at the pilot level R&D.
Is it available in India?
If you want to take it up as a venture, you can go to ARCI, that is in Hyderabad.
Yes.
It's an institute of the Department of Science and Technology. They make aerogels, and you can understand the basics. And this can be done on a small scale, and then you can graduate further. It will be very, I would say, potential venture for anybody.
Okay, sir. Thank you.
If you want to become an entrepreneur, it's a good idea. I can assure you. I can help you, right? Is that all right? Okay. How do we get to know somebody else in the waiting, or? That's okay? No. Thank you. All right. Along with this, I have, I don't know, what should